Welcome to iOS Insights. Today we'll be implementing our Guess the Word game using Swift, SwiftUI, SPM, which is Swift Package Manager, graphics, and async and await with JSON. We will start to implement the game functionality within the content view. Click within your content view and then select Tutorial and then select File and then click on Add Packages, as we'll be embedding Swift Package Manager graphic package, which is called Confetti SwiftUI, to enable some animation within the application. And then the package we'll be using is called Confetti SwiftUI, which is this one here. And then click on Confetti SwiftUI on the left hand side, which is this one highlighted. To add the actual package, click on Add Package. And then click on Add Package again. For those that know, Swift Package Manager, SPM, is similar to CocoaPods, but Swift Package Manager is more focused and aimed at iOS, Swift, and Mac environments. When the Swift Package Manager has been downloaded, you should see it in your package dependencies, which is here on the left hand side. And then you should see like images and other sources. So now we'll go back into the content view. And to use the Confetti SwiftUI framework, all you have to do is just type in import Confetti SwiftUI, just select it. Now the variables we'll be using for the application are the following. Just @state private var current word, and then another @state private var shuffled word, @state private guesses. This will include an array of guesses. Also, please note the actual solution, the source code, is all downloadable by iOS Insights. They can download the whole thing. @state private var end of game equals false. @state private var display word equals comma, and then @state private var attempts equals 0. The attempts is the amount of attempts it took to find the actual word. At states, private, var, second, elapse, and seconds elapse is used to count the amount of seconds that it took to find the word. At state, private var, show balloon equals true. And show balloons appears at the end of the game when the word has been found. At state, private count equals int 20. At state, private var start new game equals true. At state, private var attempt guess equals false. And at state, private var game count equals 0. At state, private var letter buttons is hidden equals false. And then finally, the final variable is let timer equals timer publish 1 and then on dot main then in dot common then auto connect. So this line 26, it creates a new timer that publishes a new value every 1 second on the main thread and in the common run loop mode. I missed out to the declaration of var, which is variable, so I need to add var here and also var here. And then now within var body sum view, we'll create a scroll view. So scroll view bracket vstack text guess the word. But then we need a bracket there. And then dot modifier text modifier, open bracket, color, nil. So now we just run it. What we should see on the screen is the caption, guess the word, within a text that's embedded within the VStack. So we just run it now, just to make sure that it's working. Oh, there's a bracket missing, so I missed out a bracket. Hold on, something happened with Xcode. It's just compiling at the moment. As you can see, it's displayed guess the word at the top. So that part is working, which is good. I'll just place it here. So the next thing we need to do, oh yeah, about modifiers. So modifiers enables encapsulation, code reuse. So the modifier enables things like the text and the font alignment, highlights, italic, bold to be embedded so that you don't have to keep on typing it out. You just create a modifier. But all of this is explained fully in the code download that's available by iOS Insights website. And it's also available on YouTube, the actual link for the website. So create another text field, which is text, open bracket, display word, add another modifier, call this modifier text modifier, the same as the previous one. The color will be yellow. And now we create another stack. This time it will be a H stack, which is H stack. Just type in H stack, open bracket, and then close bracket. For each guesses ID, self, guess in text, open bracket, guess, dot font, open bracket, headline, dot font, foreground color is black. As you can see, this is another modifier, dot foreground, open bracket, dot black, and dot font, open bracket, dot headline. This modifier could be encapsulated into this folder that has all the modifiers. So create another element. This one will be a text field. It's called text field letters, letter display, text at current word, current words. I think I missed out a variable. Did I miss it? Current word, current word, at current word. Well, for some reason it's not working. Let me try it again. Current word. Letters, display, comma, text. Oh, it's $, current word. Dot text. This is another modifier, but really it could have been an embedded modifier, like an encapsulated modifier, stored within the modifiers file. Storing it in the modifiers file enables better code reuse than doing it this way. I'm just showing you all different combinations of how to do it. Text field, style. So we make the text field style rounded. Border text field style. And the modifier letters display modifier. So let's run this again just to see the latest output. As you can see, it's created a text field, text box, and the text field will display the actual letters that have been found. On change open bracket of current word new value in, this is a closure, on change, it seems like this is incorrect, on change if new value dot count is more than 1, current word equals string open bracket, new value, dot prefix. The prefix. So what this line does is just make sure that the user, as in the player, they cannot enter more than one character. So even if they try to enter more than one character, it would always take the first character and store it into the current word variable. And then now, just type in on submit. Check guess. So with on submit, when you submit, it'll always call the check guess function, but it's not being declared as yet. We'll declare it later. And now to create the actual buttons that enables the user to select the letter that they think is in the word, we'll do this. Letter buttons current word and then is hidden letter buttons is hidden. So what this will do, as soon as the application has been launched, it will hide the letter buttons. And this is done by setting letter buttons is hidden Boolean variable. If start new game and not attempt guess open bracket, so this means it's the start of a new game. So obviously if it's the start of a new game, the game hasn't started as yet, there hasn't been any guesses made, so that will always be true. So create a spacer, 2 spaces, to bring the button down a bit. Button, open bracket, new game, action, new game, dot modifier, new and end game modifier. And then the next if statement is similar to the previous one. Really, this should be refactored to enable better code reuse, but that can be done another time. If attempt guess and not start of a new game, and create the same spaces as before. I'll just copy this, copy and paste this. And that will be guess. This will be the guess button. So when you think you know the word or the letter that's in the word, just click on the guess button. And then the action will be check guess. Check guess. If end of game text open bracket comma font system size 50 dot on appear counter plus equals 1 start new game equals false attempt guess no yeah, that's incorrect. Start new game equals true. Attempt guess equals false. Game count equals 1. So this section, what it does, it shows the confetti when it's the end of the game. And the actual confetti functionality will be coming up soon. Type in dots, confetti, confetti cannon, counter, counter, repetitions, and repetition interval. So all this means is that the confetti will be shown 3 times, but during that 3 times it will be shown every 0.7 of the times, as in seconds. Now to display the actual result to the screen, as in display the result of the game and the time taken to guess the actual word, this information will be displayed within the text. So just type in text, you guess the word in attempts in attempts and seconds elapsed and seconds. So this one attempt, is it working? Attempts. hold on, I think we missed out something. Attempts. I spelled attempts incorrectly, so there should be a T there on line 17. Font, open bracket, title. So now we're just styling the text field, the text box for the words. So we're giving it a font style of title, foreground, got white, and then play sound. So the play sound is played when the game has been completed, when the word has been found. And this play sound is within a modifier. So it's all encapsulated. It's in this modifier, play sound modifier. Dot on appear, open bracket, UI application, dot shared, dot send, action, open bracket, selector, open bracket, UI responder, UI responder, UI responder, design, UI responder, it's UI responder, dot, and then it's resign, first responder, to nil from nil and for nil. On line 89, all this does, it just removes the keyboard from the application. Delete that bracket, it's not needed. The on appear, why is this one red? UI application dot shared send action open bracket selector open bracket UI responder design first responder. Oh, there shouldn't be a bracket there. Expected declaration. So why is this red? It seems like this is in the wrong place. So I'll cut this and delete these two here. Then I place it here. Dot on appear. And then type in get random. Well, let's just see how it works at the moment. Oh yeah, we can't because the other two methods haven't been created as yet. So just type in get random words. Get random words. That's another method that needs to be created. And on.receive. Open bracket timer. In if not end of game, seconds elapsed. Let's increment the seconds elapsed to 1. And then set the background color This background color is using an extension which is 0x. This is the hex value for the background color. F8 4 B8. Now type in func new game. New game, this is one of the methods that we declared earlier, but it wasn't created fully, which is new game. I just searched for it. New game. Which is here, new game. This is the method that we just created, which is called new game. Guesses, remove. Because it's a new game, we want to remove or empty the array, the variable array, so remove everything that was in the array previously. So remove all. And get random words. That's another method we need to create. This method gets the actual random words from the web service. Current words equals comma. Just clear it. Clear the current word. End of game equals false. Show balloons equals false. Start new game equals false. Because the game has already started, we won't be starting the new game again because we're in the game already. attempt guesses equals true. Letter buttons is hidden equals false. The letter buttons is like the virtual keyboard, but it's more customized equals false. Shuffle word equals word to guess. Word to guess. Word to guess hasn't been defined. Word to guess. Word to guess. So let's just scroll up just to make sure we defined it. Oh, we missed it out. So it should be called state private var word to guess string optional. And then now let's type in display word equals string repeat count shuffle word dot count. So what this line does, 108, it replaces each letter with an underscore. And this should be repeating, not repeat. So that should be repeating. This one here. Attempt equals 0. And that will reset the number of attempts, as in trying to guess the word, as it's a new game at the moment. We're in the new game function. So within the new game function, we just initialize everything as fresh. Seconds elapsed equals 0. So the new game function, that's now complete. So the next function we'll do is show word. So function show word. Guess string. So the function show word takes a parameter, which is string data type. Var new display. Var new display word, equals comma, just clear it. For open bracket index letter in shuffled word enumerated as we're going through a loop. If display word display word dot index open bracket display word shut start index offset by index. Is that right? Offset by index. 1, 2, 3. Display words. This is display word. Oh, this should be on line 116. This one here. The first bracket should be a square bracket. And then we end it with a square bracket. So if it's not equal to an underscore, so that line, it just checks if the letter has been found or not. Open bracket. New display word equals string display word open bracket display word index open bracket display word start index offset offsets by index. So if the word has been found, what we'll do is add the previous found word to the new word and update the display. Else, if guess contains letter so this line, it just checks to see if the guess contains, if the letter is within the actual hidden word. New display string letter else new display word plus equals concatenate. That means else just concatenate with another underscore. So you'll just add another underscore to the display word And now, do now, so, yeah, so now we just type in display word equal display word. Display word equals new display word. We just indent some of this to make it a bit neater. Go to file. Oh, it's indent now. So it's editor, structure, and then right indent. Yeah, so this line should really be down here. And this one is the end of the function, which is this function. And the next function we'll create is called check guess. Just type in func, check guess, let guess equals current guess, current word, dot uppercase. So just convert each letter to uppercase. If display word equals shuffled word, end of game equals true. Show balloons equals true. Letter buttons is hidden is equal to true. Show word guess equals to guess. Show word guess shows the actual correct word to the screen at the end of the game. Display word, the W should be a capital on line 129, so the W should be capital. And it should be 2 equal signs as well. Then type in dispatch, Q, main, async after. If you want the event to be taken place 5 seconds after, now plus 5. Async, this wrong. Async after deadline and the next thing we'll do is animate the words well done. So what we'll do, we'll type in with animation open bracket animation dot ease in out open bracket duration 3 seconds. Display word equals well done. And then just type in return. If not guesses dot contains open bracket guess guesses dot append open bracket guess show words open bracket guess, and that's guess attempts plus 1. So what this is doing on line 141, if the guess is not a repeat, then add the guess to the list of guesses. So just append it to the array. And then on this line, it will just update the display words. And in this line, it will just increment the number of attempts that is taken to guess the actual word. And now the final function that we'll create is to get the actual random words. So this one's called func get random words, get random words. This is a sync and await, so create a task and then do. Because we're using or doing a web request or synchronization connecting to a web server externally, we need to use task so that we're on the correct thread, which is the background thread. So let random words API equals random words API. And the random words API, that's an API that's created in this file, random words API. So when you download the source code, you get all of these files that's needed to enable the actual quiz game to function correctly. Let words equals try await random words API JSON. On line 152, it's just calling the JSON method of the random words API to get the word from the API. And then you can like display the actual random word on the print screen. Word. Then words to guess. Words to guess. I think we missed out that one. Words to guess. No, is there a word? Oh, that should be called words to guess. Words to guess. So the words to guess is equal to the word to, uppercase. And then now what we do, we create a catch block to catch any errors. And then we display any errors to the console. Print error fetching JSON. Then error. Now let's see how it works now. So we just run it now. Background, words, I guess. Words, so it should be words. Background, so that should be background. Let's try it again. So it's built, so that's good. And this is the actual game for the output. So to start the new game, as you can see, because I use the print statement, you can see the actual random word here on the console, which is here. So to start the game, just click on new, and that's generated that line. That line is the actual, or the amount of letters that we need to find. So the first word we need to find is called animalistic. So just type in A. As you can see, it's there. But if you type in a letter that's not there, it won't appear on the yellow line, like Z. It appears there though. Because the black letters, they're all the letters that's been entered or that you've submitted. I. And M. Then C. L. N. So we've done I already, so S. And then T. And then when you're ready to make the final guess, just click on guess button. As you can see, it shows the amount of attempts that it took to find the actual word, and the amount of seconds that it took to find the words as well. To use the Random Words API, you need to register on this website, which is here. It's called api-ninjas.com API Random Words. So just create an account, and then when you create an account, you'll be assigned a API key, and that API key is where you enter your API key in here. So your API key will be entered on this line 19, within the Random Words API. And then the actual URL for the Random Words API would be this one here. But all of this will be explained in the actual code solution that's downloadable from iOS Insights. So we have now come to the end of this tutorial video. If the video was helpful, please comment, like and subscribe. And I'll see you next week. And also remember that you can download the actual source code from iOS Insights, which is here. So it's www.iosinsights.co.uk. Okay, thank you. Bye. In today's tutorial, we will be creating a basic version of the Space Invaders game in SwiftUI. The game will enable the player to shoot enemy spaceship invaders. For each spaceship that is destroyed, the player gets 1 point. The player has 3 lives to start with. This is what we will be building. So this is a basic example of Space Invaders. As you can see, for each enemy that we destroy, we get 1 point. I've got about 4 points so far. And I've got 6 points now and 3 lives. So this is the game that we're creating, which is a basic version of Space Invaders. Within your SwiftUI project, create a new struct and call it bullets. Select Swift file, click on Next, and name it Bullet. Click on Create. And now we create our struct, bullet, identifiable, the purpose of making it identifiable is so that the bullets can be within an array, a loop, so we can cycle through the bullet struct using a for loop or some type of loop. Var ID, UID. Each bullet will have a unique ID. Bar position, CG point. That should be CG point. And the purpose of that attribute is to represent the position of the bullet. and create another variable called velocity CG vector. And the purpose of that variable is to represent the velocity, the speed, and the direction of the bullet. And then we need another variable called isPlayerBullet. Bool. And the purpose of this property is to indicate whether the bullet is a player bullet or one of the enemy bullets. The next struct we need to create is called Invader. Create a new Swift file. Invader. Similar to before, make it identifiable. Bar ID, as before, we give it a unique ID. Bar position, CG point. That's the current position of the invader, which are the enemy spaceships. Bar image name, string, and that will be the image for the invader, the actual ship. The next view we need to create is our game overview. So this will be a SwiftUI file. Select SwiftUI view. Click on Next. Name the file Game Over View. We can delete our preview. After lines 10, enter the following: bar, score, int, bar, restart, action, void. The purpose of that closure is to restart the game. On line 14, we need to create a VStack. Text. Game over. Font. Large. Title. Foreground color. Red. Padding. And then we need to create an element for the score. To display the user score. Font. Headline. Foreground color. White. dot padding button action restart action. So when the button is clicked on line 25 with an action, it will call the restart action closure. Restart, that's for the caption of the button. Dot foreground color dot white dot padding dot background dot blue dot corner radius dot 10, and then after lines 32 we will just set the background color of the game overview to black. Background color dot black dot edges, ignoring safe area dot all dot padding 20. I'll just compile it. In next week's tutorial, we'll start to add the game functionality to the content view. In this tutorial, we'll start to implement our game functionality within the content view, but really the functionality should be within an MVVM structure, but maybe we'll do that another time in a different tutorial. But for now, all the game functionality will be in the content view. Open up your content view, and then we have to add a few at-state variables. Which includes the following: at-state private var player position equals CG point X UI screen main bounds divided by 2 Y UI screen dot main dot bounds dot height minus 100. The purpose of that line is to enable the player's spaceship to start in the middle of the screen. I think there's a spelling mistake somewhere. Main dot bounds dot width. We also need another variable, at-state variable, at-state private var bullets equals bullets for an array of bullets, an object array of bullets, at-state private var invaders, which are the enemy spaceships, invaders, invader object array, at state private bar invader direction CG float equals 1.0 at state private bar players lives 3 at state private bar game over equals false at state private bar timer at state private bar invader bullet timer at state private bar can shoot equals true at state private bar score equals 0 at state private bar no, that should be constant. Let player speed CG floats equals 10. Let invader speed CG floats equals 5. So the next thing we will do now is to start implementing some of the functions. So the first function we will implement is called start game. We implement that after line 34. Func start game invaders equals we need a function called create invaders. I'll just comment that out for now because we haven't created that function as yet. Players lives equals 3. Game over equals false. Timer equals timer dot schedule timer. So for the time interval, that should be 0.1. And then we just need repeats, true. And then within our closure, I think there's an error somewhere, schedule timer And that should be with time interval. And then we have to create a few methods here, which is update bullets, update invaders, check collision, check game over. So what this line does on lines 41 to 47, it will execute all of these functions within a loop repeatedly. That's why we put the value true with the repeat. So it's repeating it all the time. So I just remove the comment from that line. And then we need another timer event after line 48. And the purpose of this timer event is to enable the invaders to shoot bullets. Invaders, invader bullet timer equals timer schedule. Similar to this one, so I just copy and paste it. Just paste it there. And then we have to call the method invader shoot bullet. So with the invaders, this will be done continuously in the loop, so that within the timer event, so that the invaders are shooting their bullets every 0.1 seconds, which is there. So the next functionality we need to start on, although we need to implement these later, the next one we need to start on is called create invaders. The create invaders functionality will create the actual enemies that will be shooting back at the player's spaceship. Function create invaders, which will return an array of invader objects var invaders equals invader. It creates a new instance of the invader object as an object array. Let rows equals 5. Let column equals 5. Rows equals 3 and columns equals 5. And what that does, it defines the number of rows and columns for the invaders. The next thing we need to do is to define the spacing between invaders. Let spacing CG float equals 60.0, 60 pixels. And then the next thing we need to do is to loop through each row and column to create the invaders. For column in 0 dot dot column, list of columns. Let x equals spacing times by CG float column plus spacing divided by 2. Let y equals spacing times by CG float row plus 100. And what that does, it calculates the x and y position of each of the invaders. And then having the position, we need to pass the x and y elements of the invader's position onto an array. So this is what we need to do now. Invaders, got append, invader, create a unique ID. The position is CG point x and y. We just pass x and then y. And then for the image name, it will be called invader.image invader.image name. And for the actual invader.image name, which is this one, I'll be using this image, which is on my desktop. This one here. I'll just pass that to my assets folder. Then rename it. So these type of images, you can download them from Google. Then the next thing we need to do is after line 72, just return our array of invaders. So now what I'm going to do, I will comment out these functions that don't exist at the moment. And now I'm just going to compile it just to make sure everything is okay. So there should be space on line 50 after equals timer. I'll just compile it again. It's compiling. It's compiled. So the next function we need to create is called, I don't know if we should call it player shoots bullets, or if we just call it shoot bullets. So we'll create that function after lines 75. Func shoot bullet let bullet start equals, and it should be start equals CG point XY. For X, we supply the player's position dot X, and for Y, we supply the player's position dot Y minus 30. And what that does, it will calculate the starting position of the player's bullet. That will be about 30 pixels above the tip of the spaceship, so that we can see the bullets coming out of the spaceship, of the player's spaceship. Let bullet n equals CG point X player position dot X Y equals 0. And what that does, it defines the end position of the bullet just above the top of the screen. Let angle equals at tan 2 bullet n dot Y minus bullet n dot Y bullet n dot X minus bullet start dot X. Bullet n dot X minus bullet start. Yeah, this one's incorrect. It should be bullet start dot Y bullet n dot Y minus bullet start dot Y bullet n dot X minus bullet start dot X. And what that does, it calculates the angle between the start and end position to determine the bullet position as it's like triangulating on the screen, like moving across the screen. And then the next thing we need to do is to calculate the velocity of the bullets. Let bullet velocity x equals cos angle times by 10. Let bullet velocity y equals sin angle times by 10. And then the next thing we need to do is to create a new bullet instance. And then we have to add that bullet to our bullets array. So just type in bullets, dot append, bullet, UUID, position, bullet, start, velocity, CG, vector, we need a CG vector that has the overloaded dx and dy, which is the second one here. And then for the dx, we need to pass in the bullet velocity x, so that's bullet velocity x. And for the dy, we need to pass in the bullet velocity y. Is player bullet true? I'll just compile it just to make sure it's all okay. In next week's tutorial, we will add the Invaders shoot bullet functionality and the check collision functionality. In this tutorial, we'll be implementing 3 methods within the content view. The 3 methods include move player to enable the user to move the player, and update bullets to loop through the bullets currently active in the game and remove bullets that have moved off the screen. And also we'll be implementing a method called update invaders. The purpose of that method is to enable the movement of each invader to move horizontally across the screen. So that's what we're doing in this tutorial. Within your content view, add the following method, which is called move player func move player to location CG point let new x equals min max location dot x 0 UI screen dot main dot bounds dot width player position dot x equals new x. So the purpose of that method is to limit the player's movement within the screen bounds, so that the player is always on the actual screen and they can't never scroll off of the screen. Our next method that we need to create is called update bullets func update bullets for I in 0 dot dot less than bullet dot count. So we're looping through all of the bullets in the array. Bullets dot position dot x plus equals bullets open bracket I dot velocity dot dx. And then we do the same thing for the Y position. Position dot Y velocity dy. And then we exit the loop. Bullets equals bullets dot filter $0 dot position is more than 0 and $0 dot position. Now this one should be $0 dot position dot y. And this one should be dot y as well. It's less than UI screen dot main dot bounds dot height. So this method, update bullets on line 96, it loops through all the bullets that are currently active in the game, and then on lines 98, it updates the X and Y position of the bullets based on its velocity. On line 103, it removes the bullets that have been moved off screen above the top edge of the screen. And then the other method we need to create is called update invaders. And what we need to do is to loop through all of the invaders in the array. And then for each of the invaders in the array, we need to get the X position and the invader's direction. Invaders position X, and we concatenate it with the invader's speed multiplied by the invader's direction. And then we need to check to make sure that the invaders hasn't reached the edge of the screen. Position.x more than UI screen. Main bound width -20 or $0 position x is less than 20. So if the invaders have, or they're near the end of the screen, what we need to do is to move each of the invaders downwards towards the screen, so the invaders reach the bottom of the screen. For I in 0 dot invaders dot count, invaders open bracket I dot position y plus equals 10. So for each 10 pixels, each invader will be moved downwards to the screen. I'll just compile it, make sure it's okay. In next week's tutorial, we will add the functionality to enable the invaders to shoot bullets and to also to check for collision detection. So the purpose of collision detection is that it enables the player's lives to be reduced each time when they are hit with one of the enemy's bullets. So that is for next week's tutorial. In this tutorial, we will enable the invaders to fire their bullets to the player's spaceship. As you can see here, the invaders are firing their bullets to the player's spaceship, and then the player's spaceship gets destroyed. And we'll also add the collision detection so that when the player shoots their bullets at the enemy gets destroyed, as you can see there. And for each enemy that gets destroyed, the player gets a point. As you can see, there's 4 points. Now it's going to be about 6. So that's the functionality that we're creating in this tutorial. Within your content view, create a new function called invader shoot bullets. I'll just create that after lines 119. Func invader shoot bullet. If not invaders empty, let angle equals a tan 2 bullet end dot y minus bullet start dot y. Bullet n dot x that's spelled incorrectly, so that's bullet end dot x minus bullet start dot x. The variables, they're not defined. I thought the variables were defined at the top of the program near the content view. So I'll just define them here. So we need a variable called let bullet start equals CG point X invaders, invader position. Invader position. Invader position dot X. So we need to define that variable, but I thought it was already defined. Let invader position equals to invaders random invader index dot position. Let random invader index. This is another variable that should have been created at the top near the content view. Index equals index dot random in 0 dot dot less than invaders dot count. So on line 126, we just need to fix this one, which is invader dot x, comma, y, invaders, position, y plus 20. Is that correct? Invader position. No, that should be position and not direction. Invader position. That's spelled incorrectly. It should be POSITON. Invaders position. and then bullet ends. We need to define bullet ends on lines 127. Let bullet end equals player position. And then next thing we need to do is type in the following. Let bullet velocity x equals cos angle times by 10. Let bullet velocity y equals sin dot angle times by 10. And then now we need to pass the bullet object onto the bullets array. Bullets dot append bullet UID, generate an ID, position is bullet start, velocity, CG vector, and we use the DX, DY overload, and then we pass in the bullet velocity X for DX, and we pass in the bullet velocity Y. Is player bullets? No, which is false. It's the enemy bullets. Now just compile it. Just compiling. Within the invaders shoot bullet function, what's happening is that the first thing it does, it checks to see if there's any invaders remaining in the game. And then it, by using the invaders dot is empty, not is empty, what it's doing, it will choose a random index from the invaders array, which will represent a random invader. And then it gets the position or the coordinates of the invader at the chosen index, which is on line 125. And then it calculates the starting position of the bullet, which is bullet start, which is on line 126, this one here. So because the bullet's starting position is just below the invaders, we need to add a 20 pixels between the invaders' position top position, which is the Y coordinate. And then on line 128, it calculates the angle in radians between the bullet starting position just below the invader and the player's position. And then this will determine the bullet's direction. And then on line 129, it computes the x components of the bullet's velocity using cosine of the angle. The bullet speed is set to 10 units in the direction determined by the angle, which is here. And then on line 131, it creates a new bullet object with properties such as a unique ID, which is the UUID, the starting position of the bullet, the velocity vector, which is the bullet velocity of X and bullet velocity of Y. And then we just add true or false to indicate if it's a player's bullet or enemy bullet. And then we add the actual object onto the array. So that's what we do here. So it passes all of these attributes to the bullet's constructor, the init method, initializer. And then it passes the actual bullet object onto the bullets array. So yeah, that's it for this week's tutorial. I thought there'd be enough time to do the collision detection functionality, but there isn't, so we'll do that next week. So next week we'll do the collision detection functionality and the check game over functionality and the restart game functionality. In this tutorial, we will create the collision detection functionality and the game over functionality. The purpose of the collision functionality is to increase the player's score when an invader has been destroyed. Within your SwiftUI view, within your content view, create a new function called check collisions. The next thing we need to do is to loop through each of the bullets, which is the bullets array. And then to loop through each of the invaders. That should be invader in invaders. And then the next thing we need to do is to check if the bullet and invader are close enough to collide. We type in if abs, bullet, position, dot x minus invader position dot x is less than 20 and abs bullet position dot y minus invader position dot y is less than 20. That should be 20, not 29. And bullet is a player's bullet. So if all of that if statement is true, the bullets of the for each array has the wrong name. That should be bullet with one T. If all of this within the if statement is true, then that means a collision has been detected. So we need to remove a bullet from the bullet array. Bullet index equals bullet dot first index where $sign dot 0 the ID is equal to the bullet ID. So where they're the same, we want that bullet to be removed from the array. Bullets dot remove at the bullet index and then also we want to remove the invader from the screen because it's been destroyed. So just type in safe unwrapping and then invader index equals invaders dot first index. So we can do what we've done previously. Just copy this line. Paste it there, put a full stop there. And then for the ID, that's the same, but we need to use invader instead of using bullet, so that's invader.id. And a close bracket there. And the close bracket should be there, and the open bracket for the if statement. And now the next thing we need to do is to remove the invader from the array index, invader index, and now because the invader has been destroyed by the player spaceship, we can now increment the score by 1 point, and then the next thing we need to do is to exit the loop, so we use break. And now the next thing we need to do is check for collision between the bullets and the player, so that the player's lives can be reduced each time when they collide with one of the invader's bullets. So to do that, we need to implement that functionality after lines 155. It's a little bit similar to the previous one. For bullets in bullets, if abs, what I can do, I can copy some of this on line 40, because it's a little bit similar, and paste it on line 159. If abs bullets dot position dot x minus player position, and it should be player incorrectly, minus player position dot x is less than 20, and abs bullet dot position dot y minus player position dot y is less than 20, and it's not a player's bullet, because we don't want the player to collide with their own bullets. So if it's not the player's bullet, that means it is the invader's bullet, the enemy's bullet. So if that is true, that means collision with the player's bullet has been detected. Bullets dot first index, where $0 is equal to bullet.id. So the bullets, that bullet will be removed from the bullets array using the bullet index. And because the player collided with the bullet, with the enemy's bullet, we need to reduce the player's lives by 1. -1, and it should be -1. And then the next thing we need to do is to check if the player has any lives left. So if the player's lives is less or equal to 0, that means that the game has ended. Game over equals true. we also need to stop the game timer. Invalidate, timer.invalidate. Invader bullet timer dot invalidate. So we stop all the timers, and then on line after line 173, we just break out of the loop. The next method we need to create is the check game over function. Check game over. If invaders dot is empty, so if there are no invaders left, then game over is equal to true. But what else could be done here? Instead of ending the game when there's no invaders left, we could just add another level. So if all the invaders have been destroyed, go on to like level 2. But maybe I'll implement something like that in another video. Timer question mark dot invalidate, stop all the timers. Invader bullet timer, invalidate that one, stop that one as well. The next thing we need to create is our restart function so that the user can play the game again. Bullet dot remove all. Invaders dot remove all. So what we're doing here, we're just removing all items from the array. Players' lives equals 3. It's a new game, so the players have their lives back again. Game over equals false. Score equals 0. Invader direction equals 1.0. And then the next thing we need to do is to restart the timers by using timer.invalidate, and then restart the invader bullet timer. As I said before in the first tutorial, this design should really be implemented using MVVM or something similar. But maybe I'll do that in another tutorial if anyone wants it. Start game. I'll just compile it now. In the next tutorial, we will implement the actual content view body so that the game is fully functional, and we'll call the methods that we implemented in this tutorial, in the previous tutorials. So that way you see the actual gameplay in action, and that's for next tutorial. In this tutorial, we will add the UI elements to the body within the content view. The first thing we need to do on lines 27, add a Z-stack, and then we need to delete the lines between 28 and 31. And then we type our if statement, if game over. And the purpose of the if statement, if the game is over, we want to display our game over view. And within the game overview, we also pass our score, and to enable the user to restart the game, we pass our completion handler, our closure. So that's incorrect. Typing restart game. So that's the method it should call. Else, if it's not to restart the game, that means the player wants to play a new game. So we need to display the actual player ship onto the view. And how we do this is that we use an image, system name, we just use a triangle image, fill, dot resizable, dot frame, which is the size of the spaceship, the player's spaceship. Next thing we need to do is to position the player's spaceship using the player's position variable. And then to allow the user to move the player's spaceship across the screen, we need to add a gesture. And also, we need to make it draggable. So that we can move the player's spaceship left to right using our fingers. On changed value in so within that closure, Oh, there's a D missing for change, should be changed. And then within our closure, we need to call the move player method. And then move the player ship based on the user drag location. I'll just compile it. And then after lines 40, the next thing we need to do is to loop through the bullets and then display each bullet on the screen. So each bullet has an ID, that's why we have to use \.ID for each bullet object within the array. Bulletin, rectangle, dot frame, width is 5 and height is 20. So the purpose of that line, lines 45, is to set the size of each of the bullets. As I said before, really all of this should be within MVVM model or something similar. Let's type in dot position, bullet, dot position. That's the position of the bullet, and we need to set the color of the bullet, which is dot red. Next thing we need to do is to loop through each of the invaders and display them on the screen, similar to the bullets. Invader in. And we display each of the invaders using the invader name.image name. For the image, we have to set it to resizable and then specify the size of the image, of the invader's image, the enemy's image is 40 and the height is 40. So the width is 40 pixels by 40 pixels. And then we have to set the invader's position, invader.position. The next thing we want to do is to display our score element, which is within text, UI element, which is score, to display the current score, dot font, dot headline, dot foreground color, dot white, dot position, X is 100, Y is 50, and that's the position of the score, text element, and we have to do something similar for the players' lives. I'll just copy what we've done because it's a little bit similar. Lives, players' lives. And we don't have a player's lives variable. So we need to assign that at the, oh, it is here, player's live, but it didn't come up. Oh, there it is, spelled it incorrectly. Players' lives. So that will display the remaining players' lives for the game. Foreground color should be white, and the position is X UI screen dot main dot bounds dot width minus by 100 Y 50. And what that does on 965, it just positions the player's lives label about 50 pixels away from the right, from the top right of the screen. And then we need to set the background color. Background color. Which is dot black. Now that's in the wrong position. We should also delete the padding, so the background color should be after line 69, background color dot black. It's not picking it up. That should be background. Should just be background. Background dot black, and this is the background for the actual view, for the whole view. Dot edges, ignore safe area. Dot all. Dot on appear. Again, we call our start game method. And then the next thing we need to do is to add dot on tap gesture to enable the user to fire bullets when the user clicks on the screen. If can shoot. Then shoot a bullet. So when the user taps on the screen, for each time when they tap on it, a bullet will be shot from the player's spaceship. Can shoot equals false. The reason why we need to set it to false is to prevent rapid firing. Dispatch queue. Main. Async. After deadline, which is now. Plus 0.2. So after 0.2 seconds, then the user they're able to shoot again, to fire from their spaceship. Self.canShoot equals true. Now let's run it to see if it works. Because now the game should be completed and it should be playable. So I'll just run it. As you can see, it's a playable game. We can destroy the enemy's spaceships, and for each bullet that the player fires, if it hits the enemy, you get a point for each one that's been destroyed. So if one of the enemy's bullets hits the spaceship, then the game is over after 3 attempts. So the player gets 3 lives. And then there's a little basic game over screen. Click on the button to restart the game. And as I said before, we could also add levels to this game. So when we complete the first level, this being the first level, then it gets harder and harder. So that's the game. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. The maths quiz is created in SwiftUI using MVVM. You will learn how to create the quiz so that each maths question is always unique and never repeated. The amount of questions can be set by the user. The default is 10 questions, but you can assign it to any number, for example, 1,000 questions or more if you want to. Each time the user gets the answer correct, the score is incremented and also a smiley face appears. The above is what is included in the course and it is available on iOS Insights. The full source code is already online at iOS Insights, but the first video of the course will be uploaded next week. So this is how the actual maths quiz works. For example, it shows a question, what is 8 times 3? So the answer is 24. And because it is correct, it shows a smiley face. And then it goes on to the next question. What is 9 times by 7? And the answer is 63. And then it shows the next question. What is 7 minus 4? So to get it incorrect, just say if it was like 9. So this time, we will not see the smiley face. And also, you can increment the actual questions, as I said earlier, by tapping on the plus sign if you want more questions. Or if you want to reduce the amount of questions, you just click on minus to reduce it. And all of this is using the MVVM pattern within SwiftUI. And this will be available as of next week. Within your SwiftUI project, add a new Swift file. Name the file question. The purpose of the question struct that we'll be creating will enable our maths questions to be dynamically and randomly generated. So this is what we're going to do right now. Type in struct question let number 1 int, and then number 2 int, let operator symbol equals string. Operator symbol includes things like addition, subtraction, multiplication, and yeah, that's it. And then you need another variable, let answer equal to int, let options which is an int array. So the let options depends on your option that you selected as an answer for your maths question. So this will be done by selecting one of the 4 buttons that has the correct answer. And that's why options is an array. In it, number 1 equals int random in 1 to 10. Number 2 equals int random in 1 to 10. So what that means, it'll create random numbers between 1 and 10 for numbers 1 and numbers 2. Let operator index equals to index random. Equals to int random 0.3. So what this will do, it will do like an if condition or switch condition depending on the symbol that we selected. So if it's plus, that might be at case 0, for example. That's what we'll do now. Switch operator index. Operator index case is 0, and operator symbol is plus. Answer equals number 1 plus number 2. Case equals 1. You need a semicolon there as well on line 25. operator symbol equals subtraction, answer equals number 1 minus number 2. Case is 2, then operator symbol equals multiplication, answer equals number 1 times by number 2. Case is 3, operator symbol equals plus, no, operator symbol equals divide for division, because we've done plus already on line 26, and answer equals number 1 divided by number 2. And then we need a default case, operator symbol equals comma comma, answer equals 0. Line 25, we need to delete that colon. So now, to generate the random answer options, we need to initialize an array with the correct answer. Var options equals answer. And now we have to create our actual options. So we have to loop through the options. Option.count is less than 4. So that will just keep on looping until there are 4 options. Let random option equals int dot random in answer minus 10 dot answer plus 10. And what that line does on line 45, it will generate a random number within a range centered around the answer. If not options, so if it's not equal to, it doesn't contain random option, so what that does, it checks if the random option is not already in the options array. So if it's not already in the options array, then we need to add it to the options array by using append dot random option. And then next thing we need to do is to shuffle the answer option before assigning them. So it makes it a little bit harder for the user to guess. Now I just compile it. The next thing we need to do is to create an extension. The purpose of the extension will be to hide and show when the answer is correct. Because each time the user gets the answer correct, they get a point. So create a new Swift file. Call the extension. You can just call it view extension. Import SwiftUI extension view at view builder function is hidden boolean remove all equals false, and then just return some view. If hidden, if not removed, self.hidden else self. Just compile it. So all this does, it just hides and shows the view when it's required. In next week's lesson, we will implement the Maths Quiz view model. In this tutorial, we will create the Maths Quiz view model. This will enable the questions to be generated, answers to be checked. For each correct answer, a score of 1 will be incremented. Within your Xcode project, create a new file, which is a Swift file. Name the file Math Quiz View Model. Import SwiftUI. The name of the class is Math Quiz View Model. And we will be inheriting from observable objects. because we want to observe for any changes. And then we have to create a few published variables at publish var score equals 0, which tracks the current score of the quiz. At publish var current question index equals 0. At publish var questions, which is an array of questions. At publish var quiz complete equals false, and that indicates whether the quiz is complete or not. At publish var number of questions equals 10, and that is the number of questions within the quiz. At publish var answer correct equal to false. The next thing we need to do is to create our generate unique questions method, which is a private method. Generate unique questions. And we also need a temporary array to store our unique questions, which will be generated. While temp questions dot count is less than number of questions, a nice 21, there should be an open bracket and a closed bracket at the end. Let new question equals question. So that is to generate a new question. If not temp questions dot contains $0 dot number 1 is equal to new question number 1, and $0 dot number 2 is equal to new question number 2, and $0 dot operator symbol is equal to new question dot operator symbol. So what this if statement does, it just checks if the generated question already exists in the temp questions array. And then if it does, then it uses the temp questions array. And then it appends, if it doesn't, it uses the questions temp array and then it appends the new question onto the array for the quiz. Questions equals temp questions. The next method we need to do is to check to make sure that the answer is correct or not, that the user has selected answer int, let current question equals question current question index. So it's getting the current question from the array and assigning it to the current question. If selected answer is equal to current question, the answer, score plus equals 1. Increment the score. Answer correct is true. Current question plus equals 1. That will move to the next question. If current question index is more or equal to questions dot count, quiz complete equals true. So that means all the questions have been answered. And then current question, that should be index, current question index. Our next method is called restart quiz. And the purpose of this method is to reset all the private variables to their defaults. Current question index, quiz complete equals false, and generates unique questions. I'll just compile it. In next week's tutorial, we will implement the content view. In today's tutorial, we will use the Maths quiz view model within the content view and complete the GUI functionality. The first thing we need to do is to create a new instance of the Maths quiz view model within our content view. After lines 10, just enter the following: @state object private var view model equals math quiz view model. Let button color equals red, green, blue, orange. So the button colors are the options that the user can select. That should be a comma there. So stop blue, that should be a full stop there. Show face equals false. The purpose of the show face variable will enable the application to show the face when the player gets the question right. A smiley face will be shown. The next thing we need to do is to delete the V stack between lines 17 and 22, and then add a group. The purpose of the group is to enable us to add many elements within our V stack, which we will now implement. Text math quiz dot font custom, the name of the font, size 40, font weight bold, foreground color purple, dot padding if view model dot answer question. So if the answer is right for that question, then display the smile image. So now we need to import the smile image into the assets folder. I have my smile image on my desktop, so I'll just drag it to the assets folder, which is here. And here's the smile image, which is here. I'll just drag it and drop it. And remember to name it Smile. So the next thing we need to do is only show or hide our smile image depending on the answer, if the answer is correct for the question. So we need to call our extension method, which is dot is hidden, view model dot answer, remove, dot view model dot answer correct. And what that does, it will hide the image if the view model dot answer is false. So if the answer that the user provided, if it's incorrect, then it will be hidden. Dot on appear. So for the image to be hidden, we need to do this within our thread, which is dispatch queue main async. But we need this thread to be executed 3 seconds later. So what that will do, it will set the view model dot answer correct to false after 3 seconds. View model dot answer correct is equal to false. Because before the correct answer was true and answer correct had the value true in it. So on this line it waits for 3 seconds, and then after the 3rd second it will assign it to false again, so that the image smile is invisible, so the smile will not be displayable on the screen. Next thing we need to do after line 35, I think there's a bracket missing. Let's add a bracket here. Let me just compile it. After line 34, that is now, type in the following text. Score. View model dot score. That will display the score. Font dot headline dot padding. And then the next thing we need to check is if the quiz is completed or not. If not, view model quiz complete. So if there's still questions to go in the quiz, if view model dot current question index is less than view model question dot count, so that checks to see if there's any more questions to display. If there is, then get the current question. Let current question equals view model dot question open bracket view model current index. So it gets the next question from the array using the current index, and then it displays that question by using the view model dot current index plus 1 what is current question dot number 1 current question dot operator symbol. So that might be what is 1, and the operator symbol could be plus, like what is 1 plus 2. Current question number 2. Then we have a question mark there. And I think there should be closing bracket there. No, that's incorrect. I think I missed out a comma somewhere. Current question dot number 1 current question dot operator symbol I can't see the error, so I'll just type that part out again. What is current question dot operator symbol? Current question dot number 2 question mark comma it's still the same thing. I had to restart Xcode. It seems to be correct now. So this is the next question part. So it will be like, what is 1 plus 2? So plus is like the operator symbol, or it might be multiplication, or division, or percentage. And the value there could be 2, or any number. And then now the next thing we need to do is to give the user the option to select which answer they think is correct for their question. So we need to create another B stack for each current question options ID cell option in and the next thing we need to do is to add our button action. View model dot check answer option. The text for our button will be option. As you can see, it's going through a loop for each of the 4 options. Dot font, dot title, dot foreground color, white, frame width 200, height 50, background, bottom colors, random element, got corner radius is 10. Dot padding, that should be after line 63. Dot padding dot vertical 5. So each button will have a spacing of 5 pixels between each one. And then we also need a progress view or progress bar. Double view model, current question index plus 1, total double view model question count. And then we need to add some padding, dot vertical 10, spacer, else we just display a text element that is quiz complete, dot font, dot heading, headline, dot padding. We also need another button to enable the user to restart the quiz. So we implement that button after line 79. If view model dot quiz complete button action view model dot restart quiz, and then we need to add our caption for the restart quiz button, which is restart quiz dot font title dot foreground color dot white dot padding dot background dot blue dot corner radius. After line 92, we need to create our stepper. The purpose of the stepper is to enable us to specify the amount of questions that we want to be within the quiz. If not view model dot quiz complete stepper value dot view model dot number of questions in 1 dot 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 to 20. Steps of 1. Text, number of questions, view model, number of questions, dot padding, dot on change, view model, number of questions. Let's go inside our closure, view model, we start quiz. And then the final thing we need is dot on a pair, which calls view model to restart the quiz. So as soon as the view appears, the quiz will start. Now let's try and run it to see if it works or not. Just compiling at the moment. It's compiled. So the question is, what is 1 plus 7? 1 add 7 is 8. So if I click on 8, we should see the score incremented by 1 and a smiley face for about 3 seconds. As you can see, the answer is correct, and the next question is, what is 5 take away 7 minus 2 is the answer. As you can see, the score has been incremented by another 1, so the score is now 2. So the next question is, what is 4 minus 1? I'll just get it incorrect to show you that it works correctly. I'll just say 13. As you can see, the smiley face doesn't appear. What is 10 divided by 2? 5. And we can increase or reduce the number of questions by clicking on the minus or the plus sign here of the stepper. See, if I reduce it, then there's only like 4, there's only 1 question in this quiz. If I reduce it to 1, but I can increase it to like 20 if I want to, or more. To increase it to more than 20, just change the code here. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Welcome to iOS Insights. Today's tutorial is based on creating a game called Tic-Tac-Toe, also known as Noughts and Crosses. The game will be designed using MVVM, SwiftUI and Swift. Here is a demo of the game. So I'm Noughts and the computer is Crosses. The computer won. So this is the type of game that we will be creating within our tutorial. So let's start our tutorial. So to start, create your application using a SwiftUI interface. So make sure you select SwiftUI and then click on Next. And then just save the actual application to your desktop or anywhere on your computer. And then now, what we'll do, we'll create a new class called Player. So just click on CTR, Control key, and then left click, and then click on New File, and then select Swift File, then click on Next, and then type in the name of the enum, which is called Player, and then click on Create. And then type in import SwiftUI, and now we'll create the actual enum. Just type in enum player string case naught put O there, and then for crosses type in cross equals, and then put an X there. So the enum represents the player with 0 symbol and also represents the player with an X symbol. So the players will be the computer, an actual person that is playing. And now the next thing we need to do is create another class called GameViewModel. So select and then press CTRL button, the control button, and then left click, and then select New File, and then select Swift File. Type in the actual name, which is called GameViewModel, and then click on Create. Import SwiftUI, and now create the actual class. It's called class GameViewModel observable object, open bracket, let board size equals 3. So this specifies the size of the game board, which will be 3 by 3. at publish public var board open bracket player equals array open bracket repeating array open bracket and then repeating will be nil and then count is 3 and then the other count is 3 as well. So what this does, it represents the game board as a 2D array of optional player values. Nil means an empty cell. The board is published as a property, allowing it to be observed for changes. So now what we'll do, let's just compile it to make sure everything is correct. And now let's go into content view. And then within content view, on line 10, press the return key and type in at state object private var view model equals game view model. So this creates an instance of the game view model using at state object property wrapper. And now the next thing we will do is delete everything between line 14 to 17. And also delete the padding on line 16. And now on line 13, type text noughts and crosses dot font title dot padding. So what this does, it displays the game title with a large font size and padding. And now create a VStack, which is VStack open bracket spacing 0 So the VStack is a container for the game board. Now type for each open bracket 0 dot dot is less than view model dot board size id dot self open bracket row in. What this does, it loops through each row within the board. And now type in hstack spacing, zero, open bracket, close bracket. And then within the HTAG, type for each, open bracket, 0, dot, dot, less than view model, dot, board size, ID, /self, open bracket, column, in. So this leaps through all the columns. And now create the actual buttons to enable the user to interact with the game. So just type in button, open bracket, action, so we add the button functionality later. So just enter, oh, there's a mistake here. Okay, so just enter this comment, create a button for each cell on the board. Create a button for each cell on the board. And create another comment. Handle button tap by calling the make move method on the view model. And now on line 26, type in a bracket, this bracket here. And now to apply a caption to the button, just type in text, open bracket, view model, board, open bracket, row, open bracket, column, question mark, raw value. So this gets the actual values from the 2-dimension array, as this is the dimensions, the row and the column. So what it would do, it would display the values, noughts or crosses of the cell. And now type in dot font system size 60 weight dot bold. And this sets the font size and the weight of the text. type foreground for foreground color, select foreground color, and then type in view model dot board, open bracket, row, column, equals dot naught, dot naught, so select naught from the enum, or just type it in, naught, question mark, dot red, dot blue. And this sets the text color based on the value of the cell. So if the computer is playing, the color might be red, or if the actual player is playing, it might be, well, it should be blue. And now type in dot frame, open bracket, width 100, and the height 100. So this sets the size of each cell. Let's type background, open bracket, color, and select black. And this sets the background color of each cell to black. Now type in dot border, color, dot white. And this adds a border around each cell. And now we will add some padding. So to do this, type in padding on line 38, I think. Now after line 37, type the word padding, dot padding. Now create another H stack. So just type in H stack, open bracket, spacer, and B stack, open bracket, close bracket, and type in text, CPU, wins, and then type dot font, title, and type in text, open bracket, 0, and then type in dot font, title, then type in dot font weight, dot bold. So what we're doing here, we display the label for the CPU, like the computer's name, and the points, the amount of points or the amount of times the computer has won. So in the next tutorials, we'll be making this dynamic so that the actual score is dynamically incremented. But for this tutorial, it'll be fixed for the first part of the tutorial. And now type in on line 49, type spacer. On line 51, type spacer. B-stack. Text. Open bracket. Player wins. Dot font. Dot title. Text. 0. Dot font. And title. Dot font weight. Dot bold. So this is similar to what we've done previously for the computer's player. So the same thing applies with the player's player, the human that's playing the game. So the player wins caption, it displays the label for the player and it displays the points of the player as well. But at the moment this will be fixed to 0. In later tutorials this will be automatically, dynamically generated. So now what we do, and let's try and run it and see how it works first, just to see the output. So to run it, just click on start. So it's compiling at the moment, should be loaded in maybe 10 seconds, but the MacBook is a bit slow. It's still compiling. The display is finally loaded. So this is the actual output. As you can see, it created the title that we created earlier. And this is the actual board 3x3 for the noughts and crosses functionality. And it displays the CPU caption as a player and the player's caption as a player with the points. So at the moment, we need to align this. Seems like we need to add a spacer. So let's do that now. So on line 60, just type in spacer. And let's run it again. Yeah, that's much better. And you can see now it's correctly aligned. It looks neater. The next thing we will do is add a bit of padding to the labels. So on line 62, just type in dot, padding, and then next, the next thing we will do is add button functionality to enable the game to be reset. So we do this on line 65. Line 65. So just type in, or line 66, just type in button, open bracket, action, and then, so to do the reset functionality, we'll do this in later tutorials, so just type in a comment, such as this, handle button tap by calling the reset game method on the view model. And then on line 68, add a caption to the button. We call this caption reset. So type in text, open bracket, reset. And then type in font, open bracket, title, dot padding, dot background, open bracket, color, dot blue, dot foreground, foreground color, dot white, and then dot corner radius, dot 10. So what we've done here is that we have displayed the reset button label, the caption, and then set the background color of the reset button. Then we set the text color of the reset button, and then we created rounded corners of the reset button by passing 10 to the corner radius. So now what we will do is just add a padding. So just type in dot padding, and now let's run the application to see if it's still working. Yeah, so everything still displays correctly, although at the moment we can't see any zeros or crosses, any noughts or crosses, as we're doing that functionality in the next tutorial. And you can also see the preview within live previews, but my MacBook is a bit slow, that's why I'm always running it in a simulator. So you can see the actual preview. You can click on or refresh your live preview. Probably takes a bit of time on my MacBook. So it should be shown in maybe 30 seconds. As you can see, it took a while to display the live preview on my Mac, but here it is. Yeah. As I mentioned earlier, that's why I always run the actual application using the simulator, because it's a little bit quicker than using the actual preview on my own Mac, because I need an upgrade on my MacBook. I need a faster MacBook, really. So, yeah, so what we've learned. In summary, the content view struct presents a user interface of noughts and crosses, or tic-tac-toe game. It employs the game view model to handle the game state and other functionality and logic. The interface includes a game board, a win count label for the CPU and a player, and a reset button. The at-state object property wrapper is used to manage the game view model instance. Overall, it provides an engaging and interactive experience for players playing the Noughts and Crosses game. Next week, we will add more functionality to the game to make it more interactive and playable. But you can also download the full completed game from iosinsights.co.uk. The completed version, you can also upload it to the App Store if you want to. It's fully working and playable. So that's the end of the tutorial. Until next week. So please comment, like and subscribe to keep up to date with all latest content and videos. Welcome to iOS Insights. This is the second part of the Tic-Tac-Toe, also known as Noughts and Crosses tutorial. The game will be designed using MVVM, SwiftUI and Swift. We will now start the tutorial. Open the GameViewModel.swift file and then type on line or after line 13, just type in @publish private var current player player equals .nought. So on line 15, there's an error. There should be an A there. Private. Yeah, that's right now. So on line 15, what we've just done, it represents the current player. Initially, it's set to nought, one of the players in the game. So either the computer will be player that will enable noughts to be assigned, or the user will be the player that can assign the noughts in the game. And then next, type in @published var computer wins equals 0. And again, type in @publish var player wins equals 0. So what this does, it tracks the number of wins for the computer and the player. And the next thing we do is create a method called makeMove. So just type in func makeMove open bracket row int column int. Guard board open bracket row column. So it's checking against the two-dimensional array equals nil, else return. So the check also does another check, which checks if the selected cell is already occupied or not. Now type in board, open bracket row, open bracket column, equals. equals player, or equals current player, equals current player. So what this does, it sets the selected cell within the current player's symbol. So if the current player is the computer, and if the computer is noughts, it will assign noughts to the cell. Or if it's X, it would assign X to the cell. If check win, open bracket, player, current player, open bracket, close bracket. So now what we need to do is create the check win function. So to create the check win function, just continue from line or after line 28. So just type in func check win, open bracket player, player, ball. For I in 0 dot dot is less than board size, if board open bracket I close bracket, then open bracket 0 close bracket is equal to player, and board open bracket I open bracket 1 close bracket is equal to player, and board open bracket I close bracket, then open bracket 2 equals to player. Return true. So if the current player has marked all cells in a row, return true, indicating a win. That's what that line does. Line 32. So this line also checks for the rows. Now we're going to be checking for the actual columns as well. So just type in if board open bracket 0 open bracket I equals player, and board open bracket 1 open bracket I equals player, and board open bracket 2 open bracket open bracket 1 equals player. Just have to make these brackets a bit neater. So yeah, so let's write and then return true. So what that does, if the current player has marked all the cells in a column, return true, indicating a win. It's similar to the first if statement that we've done. And now we need to check diagonal wins as well. So it's a bit similar to what we've done previously. So just type in if board open bracket 0 open bracket 0 equals player, and board open bracket 1 open bracket 1 equals player, and board open bracket 2 open bracket 2 equals player. Then return true. What this does, if the current player has marked all cells in the top left to the top right in a diagonal way, then return true, indicating a win for that player. And then do the same thing again. Board open bracket 2 open bracket 0 is equal to player, and board open bracket 1 open bracket 1 equals to player, and board open bracket 0 open bracket 2 close bracket is equal to player, and return true. So similar to what we've done in the previous if statement, but this one, what it's doing now, is checking if the current player has marked all the cells in the bottom left to the top right in a diagonal way, then return true, indicating a win. And return false. If no win conditions are met, return false, indicating no win. Oh, there's an error on the screen somewhere. Forgotten to close the loop on line 39. So just enter, just type in a bracket, closing bracket for the loop. And now we'll just compile it just to make sure everything is correct, or it can at least be compiled, even if it's not correct. So just compile it now. So to compile, click on product and click on compile, as in build. It's building at the moment. It's built now, so that's good. So now we can scroll back up to line 31 to call the actual check win function. I think this is line 30. No, line 25, 26. So to call the check win function, to check if the current player has won or not, just type in on line 26, if current player is equal to dot cross computer wins plus equals 1, just increment the count, else player wins plus 1, just increment the count, and then next thing we do is, what do you do now? Type in let winner equals current player dot raw value. Let message equals comma open bracket winner and then type in wins exclamation mark. And then the next thing we do is, what should we do now? So it's check the winner, and then you're just thinking what the next thing is to do. Check the winner. So check that one. Yeah, so we need to display an alert to show who's won and that the game is over. So we need to go onto the main thread to do this. But the first thing, we need to go to the main thread to do this. So just type in dispatch queue main async so we have to create an alert. So just put a comment here to create an alert. Create an alert. So now we have to create an alert. So to do this, we create a method called show alert. Either show alert or alert. Yeah, we create a method called show alert. So you can create this method after the line 39. So just type in private func show alert open bracket title string message string open bracket and then close the bracket. So what this function does, it defines a private function called show alert with parameters title and message for the alert. So what you do now, type in guard let windows scene equals UI application shared connected scene dot first as UI window scene. Let window equals window scene. Did I spell that correctly? Let windows equals window scene dot windows dot first else return. So what that line does, lines 43 to 44, it uses the GAR statement to safely access the window in the current UI window scene. If the window scene and windows are successfully obtained, it continues with the code, otherwise it exits the function with the return keyword. Yeah, I think there's an error because it said it cannot find window scene. Must be a spelling mistake. Oh yeah, I spelled it incorrectly there. There should be a D. Window scene. Yeah, that should be right now. Yeah, that's right. So the next thing we do is to create an alert variable. So just type in let alert equals UI alert controller title message and then message, and then just type in preferred style is dot alert. So what that line does, it creates an instance of the UI alert controller with the provided title and message, and then it sets the preferred style to the alert controller to dot alert, which displays a pop-up alert. Now I type in alert dot add action UI alert action open bracket title and type in OK. Style dot default handler and then in. So this is just a completion handler signature, and then all you have to do is type in self dot reset game. But since the game has been finished or completed, we want to reset it. Reset game. But let's comment out that method for now because it's not been created as yet. And then the next thing we do is type in, oh, there's another error somewhere. Alert title colon OK, comma style dot default handler. It seems like what the problem is to do with the missing semicolon, which should be there. So just type in a comment here to add the reset game functionality later. So now just type in window.root view controller. Root controller. Root view controller. Yeah, that's the right one. Question mark present. Open bracket. Alert. Animated. True. Completion. Nil. So what that line does is it accesses the root view controller of the window and presents the alert controller. This displays the alert to the user with the animation set to true and no completion handler is needed as we set it to nil. So now what we will do is go back to line 36 and then on line 36 we'll call the alert function. So line 36, which is here. So just type in self.showAlert and then for the actual title just type in game over, and for the message just type in message. And the next thing we do is, let's see, or maybe we do that next week. Just want to have a look. Next week we can do the other functionality to check the draw, but afterwards we just run the application just to see how it works. So for now, just type in the following comment: check draw to be implemented. So we'll implement that functionality next week. So now we go back to the content view. And now we'll call some of the actual actions of the view model. So the first thing we will do is handle the button tapping to enable the user to tap on any of the cells and display a nought or crosses in the selected cell that has been tapped. So to do that, all we have to do is delete the comments that we created last week. These comments here on line 23 to 24. And then within the button action, just type in view model, that is view model dot make move, and now type in row and then type in column. Now let's run the application to see what it does. And as you can see, the application has finally loaded. So let's test out some interaction. I'll just click on any of the squares within the grid, like the cells and the rows. So it displays a 0, as in a 0. As you can see at the moment, the computer doesn't have an option to play because we haven't created that functionality to give the CPU to play. That's what we'll be doing next week. So we have now come to the end of the tutorial of part 2 for the noughts and crosses game. If you want to download the full source code for the game, and you don't want to wait for the tutorials, you can download the full source code from iOS insights.co.uk. Also, please remember to like, comment and subscribe to keep up to date with the latest notifications. Welcome to iOS Insights. This is the first part of the Tic-Tac-Toe, also known as Noughts and Crosses tutorial. The game will be designed using MVVM, SwiftUI and Swift. We will now start the tutorial. Continuing from last week, enter into the game view model file and then on line 40 type the following: else if check draw open bracket close bracket. And now we need to implement the check draw function. So just type in func check draw. Oh yeah, also make it private. And then the next thing we need to do is it needs to return a Boolean variable. And then type in for row in 0 dot dot less than board size. Just make the screen a little bit larger. For column in 0 dot dot less than board size if board open bracket row open bracket column close bracket, and this variable should be called column, equals nil, return false. So what this line does is that if there is an empty cell on the board, return false, indicating the game is not a draw. And then on line 53, just type in return true. And what this does, it just checks if all cells on the board are filled. Return true, indicating a draw. So that should be true. And now the next thing we need to do is, oh yeah, we can add the reset game functionality. So just type in func reset game. That should be private. Private func reset game. Board equals array, open bracket repeating, array, open bracket repeating, nil, count is 3, and double count is 3. So what this does, it resets the game board by creating a new 2-dimensional array with all the cells set to nil. And now type in current player equals 0, dot 0. So navigate back to line 42, I think it is, or 40. I made a mistake. So what this should be, we need to delete all of line 40, just this section here, and also delete this one here. And now we type in a bracket, and then, is that correct? Just trying to work it out. Type in a bracket, and else if check draw, open bracket, then type in dispatch queue main async, and let's type in self show alert, or just copy this line from line 36, type this in, paste it here, and then for the message you can just type in it's a draw, type in it's a draw, and then on line 43 type another else statement. If current player is equals dot cross, open bracket. So if the current player is crosses, then call the make the computer move. So just type in actual function. It's not been defined yet, but type it in. We'll define it in a minute. Make computer move. So the make computer move function, we will define on line 50. So just type in func make computer move if let winning move is equal to find winning move, open bracket player dot cross. So we have to create another function that's undefined at the moment. So the name of the new function is called find winning move. So we'll just create it on line 50. So just type in func, or private func should be really. Private func, find winning move, open bracket player, player, open bracket row, int column, int. So what that line does is defines a function find winning move that takes the player as a parameter of type player and returns an optional tuple of type row, int column and int. So tuple, something similar to, a little bit similar to a struct. So you can have like properties, it can return more than one value. Tiny bit similar to an array. So now that we've created the actual function signature for find winning move, we can continue with the make computer move function that we started. So on line 55, just type in the brackets and now type in make move, open bracket row, winning move dot row, column, winning column. Winning move dot column, winning move dot column. And then just type in return. So what this line does is check if the computer can make a winning move, placing 3 crosses in a row, a column, or diagonal. If a winning move is found, make that move by calling the move method and return from the function. So next, what we need to do is check for blocking moves. So just type in if let blocking move equal to find winning move player.naught make move blocking move dot row blocking move dot column, and then type in return. So what that does, it checks if the computer needs to block the player from making a winning move, placing 3 noughts in a row, column, or diagonal. If a blocking move is found, it just makes sure that the caller that's making the move from that function cannot position the actual like noughts or crosses in that section. So the next thing we need to do now is type in bar available spots int open bracket close bracket. So what that does, it just choose a random spot from the available spots that the player or the computer can use to make their move. Now type in for row in 0 dot dot is less than board size. For column in 0 dot dot is less than board size. If board open bracket row open bracket column there should be a bracket here. If it's equal to nil, available spots dot append row row and then column. So what this does, it iterates through the board to find all available spots. Cells with a value of nil, stores the coordinates of the available spot in the available spots array. And then within this function, the final thing we have to type in is if let random spot is equal to available spots dot random element make move random spot 0, and this is a tuple, random spot dot 1. So what this does, if there are available spots, choose a random spot from the available spot array, and then it makes the move by calling the make move method with the chosen spot, row and column. So which one was this one? Move. So now type in if count equals board size minus 1, let row equals empty row. Return open bracket row column. What this does, if the count of cells occupied by the player is equal to the board size minus 1, one empty cell, and there is an empty cell, an empty row available, it returns the row and the column as a tuple representing the winning move. And now what we do is we just type in, just checking, yeah, just type in var count equals 0, var empty row so empty row, that needs to be an optional int, empty row colon int question mark, var empty column which is an optional int, and then just type in for I in 0 dot dot is less than board size, open bracket, if board open bracket I close bracket open bracket I close bracket is equal to player, and then count plus equals 1, else if board open bracket I open bracket I is equal to nil, empty row is equal to I, empty column is equal to I. And now what we do is we just type in the following, which is count no, we don't type in count, it's a mistake. We need to, I think we have to use a tuple, I think. Just checking. Yeah, so what we need to do is just type in the count. Just checking to see. Just type in, so it's if count equals board size minus 1, let row equals empty row, let column equals empty column, return row, and then return column within the tuple. So what this does, if the count of the cells occupied by the player is equal to the board size minus 1, one empty cell, and there is an empty row and column available, return the row and column as a tuple representing the winning move. And now we just type in count equals 0, empty row equals nil. Empty column equals nil. For I in 0 ... is less than board size, if board open bracket I close bracket open bracket board size, so we're navigating through the two-dimensional array, minus 1 I is equal to player, and count plus equals to 1, else if board open bracket I close bracket open bracket board size minus 1 minus I is equal to nil, empty row is equal to I, and empty column is equal to board size minus 1 minus I. So what that loop does, it goes through the secondary diagonals and counts the number of cells occupied by the given player. It also keeps track of an empty row and column in case there is a potential winning move. So the next thing we need to do, it's nearly at the end now, to type in if count is equal to board size minus 1, let row equals empty row, let column equals empty column, and then return the row and the column. So if the count of cells occupied by the player is equal to the board size minus 1, one empty cell, and there is an empty row and column available, return the row and column as a tuple representing the winning move. So finally we return a nil. So what the nil means is that if no winning move is found, return nil to indicate no winning move is found, as in available, it wasn't there, no one won. So now we'll run the application to see if it works. Okay, so I'm naught. And the computer hasn't made a move as yet, so it seems like we missed something out. It must be in the make move function. So let's go back to the make move function, because the computer should have applied this X somewhere in the actual grid. So let's go back to the make move function and see if we can fix that. Make move, so where's, I think it's on line 32. Or would it be here? Yeah, I think it would be here. Yeah, we missed it out. So type in current player is equal to open bracket current player equals double equals, I mean, dot naught question mark dot cross colon dot naught. So let's run it now and see if it works. Okay, so I'll go again. Yeah, this time the computer is working. I'm naught, the computer is crosses. So I'll place my naught here. Oh, so the computer won that time, as you can see. But at the moment it's not calculating the scores. So we'll just do that now. So to display the actual score, just go back to your content view that we done last week. And then within your content view, navigate to line 46. Yeah, about 46. And then we get the computer score from the view model. And the same applies with the person score, we get it from the view model as well, and display it into the text box. So all we have to do is just type in the following: view model dot computer wins, and that shows the amount of time the computer has won. That's what that does. Oh yeah, we need the comma there at the end and a comma at the beginning. And we do the same thing for the player. So I just copy that line. And then we replace that line there. Didn't copy it. Just replace that line there. And then we just type in player wins. Player wins. And now, when we run the application, we should see the scores being incremented when there's a winner. So let's run it now. So I'm noughts, the computer is crosses. But this time, I won. So the score is 1-0. So let's play again. So to play again, click on the reset button. Did we do the... Oh yeah, we haven't added the functionality for the reset button. We added the actual view model functionality, but it's not being called from the view. So to do that, navigate to the reset button on page 69. On line 69. Line 64, No, 7, line 67. And then just type in view model dot reset game, and now run it again. It's just compiling, and oh, it failed. So why doesn't it work? Let's see. So why is that not working? Let's try it again. Oh, that one's not working. Maybe set to private. Oh, that should be public. That's why it's not working. So set to public now. It will work. Just compiling at the moment. This time, I will allow the computer to win. So just place the naught there, some noughts. The computer won. And now to reset the game, just click on the reset button. And then the game is reset. We have now reached the end of the tutorial. I hope you enjoyed it. All the source code is downloadable from iosinsights.co.uk. To get all our notifications, please comment, like and subscribe. And this helps you to keep up to date with the videos as well. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. Hello everyone. Before we get started, I've set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much for your support. Let's jump in to today's tutorial. The app we are creating is called Breakout, also known as Wall Smashing Game. The purpose of the game is to destroy the wall by using the paddle and the ball. So the first thing we need to do is to create a new struct within your SwiftUI project. Select new file, select Swift file, click on next, name the file brick, click on create, import SwiftUI, type the following struct, brick, identifiable, let id equals to UID, var is hit, bool, var type, brick type, var durability is int, position CG rep, velocity CG size equals .0. From lines 18, we create a unique identifier for each brick, since we need to loop through each of the bricks. And then we create another variable that's called isHit, which tracks whether the brick is hit. And the brick type will include types such as normal, multi-hit. Durability is the number of hits needed to destroy the brick, as in the brick wall. Position is the position and size of the brick, and velocity is the speed and the direction for the moving brick or bricks. So we need to create another, not struct, but we have to create an enum, which is called brick type. So I just create a new file, Swift file, name it brick type, import SwiftUI, enum, brick type, case normal, case multi-hit, case power up, case explosive, case moving. So our enum for the brick type includes 5 cases: standard brick that breaks with 1 hit, multi-hit that requires more than 1 hit, And then we also have a power-up that releases a power-up when broken. Explosive that explodes and affects nearby bricks. And also move around the screen. We need to create another struct, and this will be for the ball, as you saw earlier in the demo. So we call this Swift file, let's call it ball. Import SwiftUI, struct ball, var position, CG point, var velocity, CG size, trail, CG point, which is an array of points. So from lines 12, what we're doing is we set the current position of the ball and the speed and the direction of the ball and the trail effects behind the ball, as seen earlier in the demo. The next file we need to create is paddle, which is another Swift file. It's another struct, paddle, var position, CG rect, so the purpose of line 11 is to set the position and size of the paddle. The paddle is that little long thing that we move across the screen to reflect the bricks. We need another file, which is another struct that's called power up. Struct power up, identifiable, let ID equals UUID, var type equals power up type. We need to create that enum afterwards. Var position, CG point, var is active, bool equals true. So from lines 13 or from lines 12 we create our standard UUID, our unique identifier for each power up. And then lines 13 includes the type of power up, such as extra life or expand paddle that we're going to create afterwards. And then the position of the paddle, or the current position of the paddle. And also whether the power up is active or not. So we use is active and set it to true. It can also be set to false when we're playing the game. So we need to create another enum. And this enum is called power up type. Enum power up type case irritable. So the purpose of the case iterable is that we need to loop through each of the cases using a for each loop. So the first case that we'll create is called expand paddle, which increases the paddle size. Case extra life. Case slow ball, which slows down the ball speed. Case extra ball, which adds an additional ball to the game. So there could be two balls whilst playing the game. Case shrink paddle, which decreases the paddle size. Case magnet paddle, which makes the paddle attract the ball. Case reverse controls, which reverse the controls for the player. I'll just save it. In next week's tutorial, we'll start to implement the actual UI for the game, which is the content view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will start to create the bricks and the paddle. So the first thing we need to do is to create a new SwiftUI file. hold down the control key, left click on the mouse, and then select new file. Select SwiftUI view, click on next, and call the file breakout game view. Within the new created view, we will add some at-state variables. So after lines 10, enter the following: at-state, private var, balls, ball, position, CG point, X 200, Y 400, velocity is the CG size, width and height. So the width is 4 and the height is -4. So the purpose of the at-state variable on line 11 is to set the position of the ball and the speed of the ball using the velocity that we'll implement later on. At-state, private var, paddle equals paddle, position CG rec, X 150, Y 500, width 100, and height 100. No, height is 20 pixels. So the purpose of lines 12 is to create the paddle with a width of 100 pixels and a height of 20 pixels. Next thing we need to do is to create an array of brick objects and also create an array of power-ups objects in line 13 we need to include the word var or the keyword var to declare the variable var. We also need to create an array of particles to have a particle effect. the particle object or the class, it doesn't exist as yet. So yeah, we can just create it now. So let's create another file, which is a Swift file. Name the file particle. Struct particle. Identifiable. So particle has an ID, a unique ID, has a position, CG point, which is the current position of the particle on the screen. It also has a velocity that includes the direction and the movement and speed of the particle, which will be CG size. Var size, which is the size of the particle, in radius, which will be CG float. Var color, which is the color of the particle. And then var opacity, which is double. And this is the opacity of the particle, as in transparency level. So we need to go back to the breakout game view. And I missed that bargain. Keep on doing that. Enter the following at state private var game timer, which is optional, and that's a time loop for the game. At state private var score, which is 0. At state private var lives. The player has 3 lives to start with. At state private var game over equals false. At state private var level is 1. Each time when the game starts, it always starts from level 1. At state private var paused equals false, which will enable the user to pause the game. At state private var magnet active, which is false, and that's a magnet power up state that we'll implement later. At state private bar, reverse, controls, which is for and then we need we need a constant, which is called number of columns, which is equal to 6. We can delete line 28, we don't need it. Add our geometry reader. Within our geometry reader, we will add our V-stack, and then we color our V-stack using a black color. Whilst ignoring the safe area. And then we loop through each of the bricks using the for each. If not, brick is hit. So we create a rectangle for the brick, and then we fill the brick with color. We need to create a new function called brick color that will return the correct color for the brick. Private function brick color for brick. Brick. And then that returns a color object. Switch brick dot type. If the brick is a normal brick, then just return blue for the color. If the brick is a multi-hit brick, return orange. If the brick is a power up, then return a purple brick. If a brick is an explosive type brick, then return red, and then if the brick is just moving, then the color will be a cyan brick. Oh yeah, there's another brick I've forgotten to include, which was yeah, that's correct for the brick color function. At the moment, we don't need any more cases. So the next thing we need to do is to go back to line 36. And then we add the following: dot frame, so we set the frame for our brick. So the brick has a width, brick dot position, width, height, brick dot position, height, position, x, brick, dot position, dot mid x, y, brick, dot position, mid y, and then to animate when a brick has been hit, we just use dot ease in, and then set the value to brick dot is hit. On line 37, we can remove the full stop, that's not needed. The next thing we have to do is to draw the paddle so that the user can move left to right. We use another rectangle, dot fill, magnet active. So if magnet is active, then the color will be cyan, else it will be red. frame, width, paddle, position, width, height, paddle, position, height, and that sets the paddle size. The next thing we need to do is to set the position of the paddle, paddle position mid X, Y, paddle position mid Y. And then we will also, there should be a full stop at the beginning of line 46. We should also animate the paddle movement, so we need to use dot animation, dot ease out or ease in out. The value will be paddle dot position. Now the next thing we need to do is to create the falling balls. For each balls dot indices ID self index in and it should be on line 49, it should be balls with an S at the end, not ball. So we need to also implement the trail of the ball. For each balls index dot trail indices ID self trail index in. That's within the closure. So to create the ball, we need to use a circle shape, and then we fill the circle with the color white, opacity 0.3. Dot frame, width 5, and height is 5. And that sets the trail circle size. And then the next thing we need to do is to position the trail circle. Trail index We'll just compile it to see if there's any errors. Cannot find color. Import SwiftUI. So we need to import SwiftUI into the particle file so that the color can be found, or so that the namespaces and imports can work. So the next thing we need to do is to create another circle on line 57, anywhere after line 57, 58, it's up to you. And then we fill the circle with a green color. The frame 20 and the height 20. That sets the ball size. And then the position of the balls, or each of the balls using the index. Just compile it again. In next week's tutorial, we will implement some of the particle effects. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the power-up features to give the player additional lives and extended paddle with extra balls. We will also start to implement the particle features as well. So we need to continue from line 64 or anywhere after line 64. and enter the following for each power-ups, power-up in if power-up is active, then create a circle and fill the circle with the power-up color. I think we need to create a function called power-up color. Yes, we do, as we didn't create it in the previous tutorial. So let's create that function. Create the function anywhere after line 77. Private func power up color. This function will accept a power up type and then return a color. Switch type. Case dot expand paddle. So if case is to expand the paddle, then we return, or the system will return, a yellow color. Case dot extra line. Return dot green. Case slow ball. Return blue. Case extra ball. Return pink. Case magnet paddle. Return cyan. Case reverse controls. Return purple. So these are our power up features that we just created. So now we need to return back to line 71. So on line 71 we need to pass the power up type to the power up color. And that will set the color based on the power up type. We also need to add a frame with a width of 20 a height of 20, which is the size of the power up. And we also need to position the power up to position it on the screen, and also to animate the power up. So we use .easeIn, value power up, .active or isActive. So the purpose of line 74 is to animate the appearance of the power up, which will change depending on the value of isActive and .easeIn. So the next thing we need to do is we need to create our particles. And to do that, we need to use a for each loop, like what we've done previously for the power up. Typing for each particles particle. So each particle will be a circle. It's a bit similar to the power up, so I just copy the lines between 71 and 74. Paste it there. And then modify the rest. Particle color. The width is particle dot size, and the height is particle dot size. Position is particle dot position, and the opacity is particle dot opacity. And for the animation, will be a little bit different. So we use the duration for the animation, which is half a second. The value will be particle dot opacity. That will animate in a fading manner. On line 84, that should be ease out, not ease in. And line 83, that should be particle dot opacity. Seems like it's spelled correctly. Let me do it again. Okay, so we need to fix something within the particle struct. And we also missed out one of the cases within the power up color function. So we missed out one of the switch cases. So the case that we need to include is shrink paddle. That should return grey. So it reduces the size of the paddle to make the gameplay a little bit more difficult. Also, on line 84, we need to remove that comma. And then we need to have a closing bracket after 0.5. So we didn't need to update the struct of the particle. So the struct for the particle, which is here, it's all okay. So nothing changes there. I'll just compile it again. So the next thing we want to do is to give the user the ability to view their scores and the remaining lives that they have. So we can implement this feature anywhere after lines 85. We will add it or include it within a VStack spacer. We use a spacer to display the scoring and lives at the bottom. VStack. So we need a text element. To score. Score. We will just style the text element with a foreground color of white for the font text, and then add a bit of padding using dot leading. Add another spacer, text element to display the amount of lives. And then the foreground color, that will be white. Another spacer, text, and this is to display the current level that the user is on. Foreground color, got white. Padding, trailing, got padding, bottom, 20. Frame, width, geometry, size, width, height, 50. So that just sets the frame for the display. Dot background, dot black, dot opacity 0.7. That will give a semi-transparent background to the score, lives and level of the VStack. In the next tutorial, we'll start to implement the pause functionality and the game over screen. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will add the resume, pause, and the game over VStack. Anywhere after lines 108, add the following: VStack, button, action, let's type in pause.toggle. So when the user clicks the button, the game will be paused. For our button text or caption, we need to add a text element, pause, and resume. So lines 115, what this does, depending on the state, it will either show pause or resume on the bottom caption. You just add some style to the font, to the title, which is title 2, And as you can see, pause is now displayed on the corner left, on the left hand corner, which is here. The foreground color white, dot padding, background, grey, dot opacity, 0.7, and that's for a semi-transparent background. So it can't find grey, so it seems like we have to use colour with dot grey. Dot corner radius, is 10, and that's for rounded corners of the bottom. Add a spacer to push the button to the top. But the spacer is in the wrong place. It should be anywhere after line 121. Also need some padding for the buttons container. Let me give it a padding of 20 just to see what it looks like. And then we also create a pause overlay. So just type in if pause and display the text. Pause. Then we can copy lines 116 to 119. And that should be large title. Color.white stays the same. Opacity, that should be color black. And then we just need some padding. And then the next thing we need to create is our game over screen. Our game over VStack. Game over. So if game over is true, then display this VStack text. Game over. font dot large title dot foreground dot white dot padding button action We also need to implement a restart game method. We'll do this next week or tomorrow. So just comment that out to add a restart method. And then for the button caption, we also need a text element with the word restart. And I'll just copy lines 129 to 132 again. The font type should be title, the color, foreground color is white, padding, background color is color.green, and then the corner radius is 10. And also we need to add padding to the button. Padding and then we just add a background color, which is color dot black dot opacity 0.8. And that is a semi-transparent black background. And then we just need ignore or edges, ignore safe area dot all. So the view will extend to the edges. So now let's see if we can show the game over screen. VStack. So if I change game over to true, let's see if the preview refreshes. With my MacBook, it is so slow. It shows it a little bit, but that should be more centered. But we can fix that in next tutorial. So please comment, like and subscribe if you haven't done. And see you tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app? but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the game loop and set up brick methods. The purpose of the game loop is to update the game state every quarter of a second. The setup brick method displays the correct brick type. After lines 158, enter the following. Dot on a pair. So we now need to create our setup brick method. Private func setup bricks. That accepts a CG size. It will calculate the height and the width of the brick. The next thing we need to do is to I don't know why it's showing an error. Oh, this should be after lines 168. So I'll just move this. And place it anywhere after lines 163. So the next thing we need to do is calculate the width of each brick based on the screen size. Let brick width equals size dot width divided by CG float number of columns we cannot find the variable number of columns. I thought we defined it in the first tutorial. Let me scroll up. It seems like we missed out number of columns. The number of columns has already been defined on line 25, defined as a constant, but it's not in the right casing, so we need to change the O to a capital O. And now the variable should be in scope and scene. Yeah, there it is, number of columns. Next thing we need to do is to set the height and size of each of the bricks. Let brick height CG float equals to 30 pixels. And then we have to randomly choose the number of rows for each of the bricks. Equals int dot random 4 to 6, which has 3 dots. And then the next thing we need to do is to create an array of bricks based on the number of rows and columns. So to do this, we need to also use a loop. Bricks equals 0 dot dot less than number of rows dot flat map row in and then we need to loop over each column to create the bricks in each row. Zero dot dot number of columns dot map column in let type brick type equals row mod 3 is equal to 0. Else it would be a multi-hit row mod 5 is equal to 0, and explosive else is normal brick. So on line 176 we just determined the brick type based on the number of rows or the row number. So the brick types can be a multi-hit or explosive or normal. The next thing we need to do is set the brick type durability, such as the brick type strength. The strongest brick types at the moment are multi-hit bricks. They have to be like destroyed or by that multiple times. So we just implement that. Let durability equals type equals dot multi-hit 2 or 1. So if the type of brick is multi-hit, that means we have to destroy it twice. If it's a normal brick, the durability is just once, so we just destroy it once. And then the next thing we need to do is to calculate the position of each brick based on its row and column. That position equals CG rect X CG float column times by brick width Y CG float row times by brick height width brick width minus 2 height brick height minus 2 and then we need to return a new brick object that includes the calculated properties that we define within setup brick. Return brick is hit false type durability position. Just compile it. So the next thing we need to do is to return to our dot on a pair on line 161 and then implement the following setup bricks. So we now can call our setup bricks method, initialize the bricks layout, geometry, dot size, we cannot find geometry. Let's see if we've defined it at the top. So here is geometry on line 28. Maybe I spelled it incorrectly, but just copy and paste it. Still can't find it. I had to restart Xcode, and now it seems like it's picking up the geometry variable, and it's now compiled. So the next thing we need to do is to create our game loop function, and that is called start game loop. And as you can see in the preview, that's what it looks like on the right hand side. Private func start game loop. As I mentioned earlier, we'll update the game state every quarter of a second. Schedule timer with interval of 0.016. Repeat is true. The invocation, we don't need that. There should be an R at the end, the timer. And we just need to check that it's not in pause mode. If not paused, then update the game. So just call update game method. And that method we need to create in our next tutorial. Just compile it. So let me comment that out. And then on line 157, you'll call the start game loop function. Recompile. So there's an error, schedule timer. That should be with time interval. I'll just build it again. In the next tutorial, we'll implement the move paddle functionality to enable the user to move the paddle from left to right. As you can see on the screen here, this is the paddle. So the ball will bounce off the paddle and collide with the bricks to destroy the bricks. So that's for that tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will implement the move paddle method to enable the user to move the paddle from left to right to capture the falling ball. This will be a shorter tutorial, so let's get started. So the function that we need to implement, we can do it anywhere really, but I'll just do it after lines 200. It's private func move paddle to x cg. That should be cg float in size cg size. Let movement equals reverse controls question mark -1 else 1. So what that does, it reverses the movement direction if reverse controls is active. And then to update the paddle position within the screen boundaries, we need to type the following: paddle position dot origin x equals min max paddle position dot origin x plus cg float movement times x minus paddle dot position dot mid x comma 0 comma size dot width minus paddle dot position dot width. And that will update the paddle position within the screen boundaries. Now just compile it. Previews, they're running a bit slowly. In next week's tutorial, we will add collision detection and enable the ball to bounce off the wall and the paddle. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will add collision detection and enable the ball to bounce off the wall and paddle. So the first thing we need to do is to create a new function anywhere after line 228. Name the function private func update game. Guards not game over. So if the game is over, then we just exit the function, else if it's not over, we just continue within this function. For index in balls dot indices, so we're looping through the balls array. Balls index position x equals, plus equals balls index dot velocity dot width. The purpose of that line is to move the ball horizontally across the screen. I'll just copy lines 234. The next thing we need to do is to move the ball vertically. So we just use position.y. And instead of using the width, we use the height. Balls index dot trail dot append balls index dot position, and that will add the current position to the trail, to the ball trail when it's moving. So you see like little faint lines. If balls index dot trail dot count is more than 10, then we need to limit the trail length of the ball. Dot trail dot remove first. So it's always less or equal to 10, no more than 10. Remove first. Below. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. The next thing we need to do is to bounce the ball off the left and right walls. So type in the following: if balls index dot position dot x is less than 0, or balls dot index dot position dot x is more than UI screen dot main dot bounds dot width. Then balls index dot velocity dot width star equals -1. The next thing we have to do is to bounce the ball off the top wall, similar to what we just done. So it's if balls index dot position dot y is less than 0, balls index dot velocity dot height times equals -1. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next thing we need to do is to check for collision with the paddle. So we need to check if the ball is colliding, hitting the paddle. If paddle.position.contains balls index.position, let hit point equals balls index.position.x minus paddle.position.min x divided by paddle.position.width let angle equals open bracket hit point minus 0.5 times by 0.5, and that will calculate the angle of the reflection of the ball when it hits the paddle. Balls index velocity width plus equals angle times balls index velocity height. The next thing we need to do is to reflect the ball upwards. Balls index dot position dot y equals paddle dot position dot min y minus 10. And the purpose of that lines 254, is to adjust the position to avoid multiple collisions. So that should be paddle dot position. It should be an I there, minus 10. If magnetic active balls index dot velocity equals CG size width and height overloads we need to use. So that will be 0, and the height will be minus abs, balls, index, velocity, height, and what that will do, that will set the velocity for the magnet effects. So in the next tutorial, we'll check for collision detection for the bricks. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will check for collision detection with the bricks and increment the score each time the ball hits a brick. So the first thing that we need to do is navigate to line 260 and then type the following. For I in bricks dot indices where not bricks I dot is hit. So where the bricks haven't been hit, if bricks dot position dot contains the ball index position if bricks open bracket I dot type is equal to multi-hit and bricks dot durability more than 1, then bricks, durability minus equals 1. So what that does, it will reduce the durability for the multi-hit bricks. Else, it will mark the bricks as is hit. It's true, so the bricks have been hit. Now that the bricks have been hit, we then update the player score by 10 points. If bricks dot type is equal to power up, drop power up. So we need to create a new method called drop power up. So let's create that method now. Private func drop power up at x cg float y cg float. And the purpose of that function is to drop a random power up at a given coordinate. So we will implement that part now. Let random power up equals to power up type dot all cases random element question mark extra line. Power ups dot append. So we append the new power up that has a type which will be accepting a random power up, and a position which will accept an X and a Y. The parameters that we just passed in previously within this function. So now we have to go back to line 268 and call the new function that we just created. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. at bricks I dot position dot midx, and for the y parameters we need bricks. So get the bricks from the array, position dot mid y, and that will drop a power up to that function. Bricks was spelled incorrectly. The next thing we need to do is, oh yeah, and on line 267 there should be a full stop and then dot power up, which is there. So line 270 we need to add particles to have a particle effect. So we need to create that function. That function we'll create later. I'll just add a comment. The next thing we need to do is to reflect the ball using velocity. Type in balls index dot velocity dot height times equals -1. And then we also need to check for level completion. So we'll add that method later. And then we would need a break statement. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next thing we need to check is to see if the ball has gone out of bounds. Balls index dot position dot y is more than UI screen dot main dot bounds dot height. If it has, then remove the ball using the index. If balls is empty, then reduce the lives by 1 if lives is more than 0, then we need to create a new method which will be called reset ball and paddle. Else, if the player has used all of their lives, then we need to end the game, so game over is true. And then we also stop the game timer. And then we also need to call update power up and particle methods. It's not being defined as yet, so we need to add this method as well. In the next tutorial, we will implement some of the methods such as add particle effects methods and some of the other methods that we have commented but not defined. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we'll start to add the particles functionality. So the first function that we will add is called add particles, and we add that after lines 299. Private func add particles at x cg float y CG float. The next thing we need to do is to create a loop between 0 and 10. And the purpose of this loop is to create the particle effects 10 times. So to create the particle effect within the loop, we have to create a new instance of the particle class. So we need to pass CG point and the coordinates x and y. Which is the position of the particles. We also need to set the velocity, which is width and height. So that will be CG floats dot random in minus 2 dot dot to 2. There should be 3 dots there. And then the height is also CG float dot random in minus 2 dot dot 3 dots to 2. And what we're doing here, we're setting the random velocity within a range for both x and y directions. And the size will be CG float dot random in 5 dot 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 10. And that sets the random size for the particles between 5 and 10. And then we just set the color, which is white, and the opacity, which is 1.0. The next thing we need to do is to add that particle instance to our particles array. It should be particles dot append particle. Just compile it. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. And now we need to go back to call our particle method, which is here on line 270. Add particles, bricks. So we pass the array of positions to our particle function. And we also pass the mid-y position array to our particles function. And that should be mid-x with a capital X. So the next function we need to implement is called update power up and particles. Private func update power ups and particles. For I in power ups dot indices where power ups is active within the array, power ups position dot y plus equals to 2, which will move the power up downwards if paddle dot position contains power ups position then we need to create another function called active or activate power up. We'll create that function later. And then power ups, open bracket, I, close bracket, is active is equal to false. So what that will do when we implement the function, it will activate the power up if it touches the paddle, but we need to create the function activate power up, which we'll do like later or in another tutorial. Next thing we need to do is to update the particle effect. For I in particles dot indices particles dot position dot x plus equals particles dot velocity dot width, which will move particles horizontally. To help upgrade my equipment, I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. And to move the particles vertically, we need to do something similar. We can just copy line 307, change it to Y for the position. Velocity should be dot height. And then to decrease the particle opacity over time, we just type in dot opacity minus equals 0.02. And then to remove particles that are no longer needed, we just call the remove method of the array, or remove all method. $0, opacity is less or equal to 0. And that will remove particles that are no longer visible. So now we can call the new method on lines 293. Let's call it here. I'll just compile it. Just compiling at the moment. In the next tutorial, we will create the activate power up function. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will create the Activate Power-Up functionality to enable random power-ups to be dropped at given coordinates. We'll implement this function after lines 328. Just type in private func activate power up that will accept a power up object. Next thing we need to do is to create a switch statement to handle different types of power ups. Case dot expand paddle. So the power up is to expand the paddle, as in increase the width. So to increase the width of the paddle, we need to type in paddle dot position dot size dot width, and then increment the width of the paddle by 40 pixels. And then if the power up was for an extra life, we give the player one more additional life. If the power up was a slow ball, then we loop through all of the balls in the array. And then for each balls within the array, we slow down the horizontal velocity of the width by 0.80. By 0.8. 0.8. And then we do the same thing for the vertical velocity. We slow it down by the height by 0.8. Else, if the power up is an extra ball, then we add a new ball to the game. So there'll be two balls within the game. So it'll be balls dot append ball position CG point. We need the XY overloads. 200, 400, CG size. We need the width height overloads. and for the height -4. If the power up is to shrink the paddle, then we decrease the size of the paddle by 40 pixels. Paddle dot position dot size dot width equals max 60 paddle position dot size dot width -40. And we also ensure that the width doesn't go below 60. That's why we use 60 here. If the power up is magnet paddle, then we just set magnet active equals true. Else, if the power up is to reverse the controls, then we just reverse the controls by setting it to true. On line 333, there should be a code on there, and line 335. I'll just compile it. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. The next function we need to add is to check if the level has been completed. So if the level has been completed, we need to increment the level by 1 so that the game goes on to the next level. So to do that, we just type in private func check for level completion if bricks dot all satisfy $% dot is hit. So what that does, it checks if all the bricks in the game have been hit. If all the bricks in the game have been hit, have been destroyed, that means the level has been completed. So we increment the level by 1. And we also need to increase the level of the game, the difficulty level. So to do that, we need to create a new function called increase difficulty. We'll add that function tomorrow. And then another function that we also need to call is reset ball and paddle. We'll create that function tomorrow also. And then we just call setup bricks and pass in the UI, screen, main, bounds, dot size. On line 358, what that will do is set up the new bricks for the next level using the screen size. But these two methods we need to create. We'll create it tomorrow. So tomorrow the entire tutorial for this game will be completed. Just going to check to see if we need to call any other functions that we added in the previous tutorial. So on lines 273, check for level completion. We can call that function now because we just implemented it. Check for level completion. And on lines 167, we can uncomment update game. So that's now a function, update game. The restart game, it doesn't exist as yet. We'll be creating that tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will create the functionality that will increase the ball's speed each time when the game moves to the next level. So the first thing we need to do is navigate to line 362, and then add the following: for I in balls indices. So we're looping through the balls array, balls I, which is the index velocity, dot width times equals 1.2. So what that does, it increases the ball horizontal speed by 20%. Balls velocity height 1.2, and that increases the ball's vertical speed by 20%. And then to make the game a little bit more harder, we reduce the paddle width by 10%. The next function we need to implement is called reset ball and paddle, which resets the ball and paddle position for a new level after losing a life. Balls equals ball position CG point. We need the XY overload past 200, 400. Velocity is CG size. We need the width and height overload. So width is 4 times by power, the power 1.2 double level minus 1. And then for the height, that needs to be minus 4 times by power 1.2 double level minus 1. There's an error somewhere, missed out something. Just compile it again. So what we've done there, we just set the ball's position and velocity, scaling velocity based on the current level. The next thing we need to do is to set the paddle's position and size based on the current level. We need the X, Y, width, height overload. X is 150, Y is 500, width is 100 times by power 0.9, double, level, -1, and then height is 20. And there's an error on line 373. Missed out something. It must be double, level, so that's power, open bracket, 0.9, comma, let's compile it again. Want to build your own Connect4 app? Now you can. Download the free source code and start building today. The link is in the description below. Set up a Patreon to help upgrade my equipment. I'm aiming for a new MacBook Pro, which costs £4,000, to improve video editing and audio quality for better tutorials. If you'd like to support, the link is in the description. Thank you so much. We next need to set magnet active equals false to disable the magnet power up effect, and also we need to reset the control scheme to normal. Another method we need to create is called restart game. There's private func restart game in size, which accepts a CG size. Game over equals false. Score equals 0. Lives equals 3. Level 1. Power ups, removal all. Remove all the particles. And then reset the ball and paddle and call setup bricks. So that sets up the bricks for the first level using the given screen size that we pass in, which is size. And then we just call our game loop. On lines 284, we need to call the method that we implemented, which is reset ball and paddle. Also on lines 139, we need to call the reset game method. Reset game. What did we call it? Reset game or something else? I mean restart game, that's what it should be. So we just pass in geometry, dot size, just compile it. And now we can try to run the game to see if it works or not. Hey, there's something else that I missed out. We have to go into the content view and what we need to do, we need to call breakout view on lines 100, on lines 12. So breakout game view, so the view gets shown at the start. Edges, ignore safe area, all. Still waiting for the game to run. Let me try it again. As you can see, this is the game in action. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Question: is this current or past basketball player? And just select or tap on yes or no. And then after that, it selects another player and you just have to select yes or no. If it's a past or current basketball player, click on yes. And then for this one, just click on no. And then yes. And then yes. And then yes. And then click on no. And then at the end of the quiz, it displays a list of results to show the correct answers that you selected. And then it also shows a percentage of the scores that were correct. So this time we got 100% correct and 0 incorrect. And to play again, just click on the play again button and then it takes you back to the first step that we showed earlier. And you can also update this quiz to add your own questions. And you can also update it so that the quiz comes from an actual API. So this is what we'll be creating using Swift and SwiftUI. Within your SwiftUI project, enter into the content view and then on line 12, enter the following: at state, private bar, current question index equals 0, at state, private bar, show result equals false. At state, private var show score equals false. At state, private var score equals 0. And then now create a new class called Player Manager. So to do this, just click on File, New, and then File. Select Swift File, click on Next, and then enter the name of the class, which is called Player Manager. And then click on Create. And then now, within the new created class, type the following, which is struct and Player Manager colon observable object open bracket and close bracket. And then above this class, also import SwiftUI. Type in import SwiftUI. And then create a struct, which is called player, struct, player, and then select identifiable. The purpose of inheriting identifiable for the players class is to enable the actual player to be looped within the GUI. So we can loop through each of the elements within the GUI if we inherit identifiable for the player class. Now enter the attributes of the player class, which is let id equals UUID. So this just creates a random ID for each player. Let name equals string, the name of the player. Let image string. Let is a basketball player. This is a boolean. It just indicates if the player is a basketball player or not. Then bar is answer correct. Is answered correctly. False. And then now, within the player managers class, type in the following. At publish var players and player. So the purpose of marking the players property as at publish, it will notify the GUI, which is the content view, of any changes within the array, just in case there is any or not. So it will submit the updated changes to the GUI. So now we just type in, oh yeah, this should be a square close bracket on line 22. This one here should be square. And then the one below it should be a closing square bracket. So now we just type in player, open bracket, name, and then for the name, we just type in LeBron James, as he's a basketball player. And then for the image, just type in LeBron James' name again, but just put the actual name all together, and that will represent the actual image. But we'll be adding images to the assets folder, which is here, later. And then is basketball player true? I'll just delete this part, it's incorrect. Is basketball player is true? It seems like that's correct. Let me compile it just to make sure. Class manager. Just compile it. Cannot find comma. There's an error somewhere. Where is that? I'm just fixing this error at the moment. So I'll type this in again. So let me select it from there instead. And then delete that one. And put the values into this one. So just enter LeBron James, enter it again, and then for the image, enter LeBron James is a basketball player, true. Let's see if this compiles. If this compiles, we just copy and paste the rest. So why doesn't that work? Struct, observable, objects, at published, var, colon players. And that looks like it's correct. Oh, I know what the problem is. This should be a class and not a struct. So that's the error. So let's try it again to see if it builds. Yeah, so it built. So now that it's built, we can just duplicate what we've done, but change the names and the images for different players. So just put a comma here at the end of line 23, and then just copy and paste it. And paste it about 7 times, I think. So it's at 4, 5, 6, and 7. And then on line 24, we enter the name Kobe And then for the image, just set this as the image. So just copy the name. And then just paste it as the name of the image. And then another name, just enter Brad Pitt. And then just type in Brad Pitt here for the image. Brad Pitt. Basketball player. This is false. So he's not a basketball player. He's an actor. And then for the next one, for the next basketball player, just enter Tom Brady. And then for the image, just type in Tom Brady. Basketball player is true. And then for the next basketball player, type in Stephen Curry. And for the image name, just type in Stephen Curry. Is a basketball player, which is true. And then for the next basketball player, just type in Michael Jordan. And then for the image, just type in Michael Jordan. And then for the is a basketball player, yeah, leave that as true. And then finally for the next person, just type in Tom Hanks. He's not a basketball player, he's an actor. For the image, just type in Tom Hanks. And then for the is basketball player, just assign this to false. Just make the actual code a little bit neater. So what we've done here, we have created an array, an object array, where we're passing in the actual values to the player's constructor, which is there. So we're passing in true to the is basketball player attribute, and we're passing in the image name to the image attribute, and the player's name to the player's attribute of the player within the constructor. So we're just like assigning the elements to this player's construct, which is here, to the struct. But really, in a real live or proper professional example, this information should be coming from an API, like a JSON payload. But for this example, it's just like being populated using an array of objects. So now we have all of the data populated within the array. We'll go on to the next phase of the application process. Back in the content view, on line 16, enter the following: at state, object, private, var, players equals player manager. What this line does, it creates an instance of the player manager as a state object. So now we have the actual values from the player manager that we can use. And then on line 19, delete everything between lines 20 to lines 25. And then now what we'll do is create an empty view. And then now type in a closing bracket. And then what we'll do now is create the NBA title view. So to do this, what we'll do is create another struct. So click on File, New, and File. Select SwiftUI file. Click on Next. And for the NBA title view, just type in NBA title view. And then click on Create. Import SwiftUI. And then create the actual struct, which is struct NBA title view var body sum view vstack text open bracket and type in NBA dot font system size 60, and then the weight is dot bold, design is dot default, foreground color is dot white, padding is dot 20 top. So what this does is that it displays the NBA text with a large bold font and a white color. And this NBA title will be positioned 20 pixels from the top. And then next, what we'll do is create our subtitle, which is text, open bracket, basketball, and we can copy what we've done here and change a few things around. So copy the lines between 15 and 17, just to save a bit of time. And then for the size, make the size 30. For the weight, keep it as bold. And the design is default. The foreground color is white. And the padding is 20, but to the bottom. And then next, type in frame, width 300, height 150. And then next, type in dot background, linear gradient, and then type in gradient open bracket, colors, and then open square bracket, color dot red, comma, color dot blue, and then for the start point, just type dot leading. For the endpoint, just type or select dot trailing. And then, is there a mistake here? Colors. Oh, we missed out the colon, so just enter the colon there. And then now, the next thing we do, we just type in dot corner radius 20 dot shadow black and the radius which is, yeah, this is incorrect, so it's open bracket color, so it's dot black for the color, and the radius is 5 comma x 0, x is 0, then y is 5. So lines 27 to 30, what that does, it applies a linear gradient background with red and blue colors so that it represents the NBA color scheme, and then it applies a corner radius of 20 to give the view around the corners, and then it applies a drop shadow effect with a black color which is here. So we'll just compile it to make sure that everything is correct, or that it compiles anyway, because it can compile but it's not correct. And then we click within the content view, so go back to the content view, and then within the content view delete lines 20, the empty view, just delete that. Now type in NBA title view, so this is the actual view that we'll be using as a title. So now if you run the actual application, we should see the new title that we just created, which is the NBA title view. So we'll just run it now. So is it running? Because my Mac is a bit slow. Yeah, so at the moment it's in the middle, but we want it to be placed at the top. So what we need to do is create a spacer. So on line 21, just enter spacer. That should be capital S. Now this will be positioned at the top. As you can see, it's now positioned at the top. On line 22, just type in this comment to do or line 23, it's up to you, 22 or 23. Just type in to do question view goes here. So the question view function to retrieve the player's photo and to retrieve the question. Like so. So if you click on yes, it displays the next player. Click on yes. Or no, it still displays the next player. So that's what we're going to be doing in this session. We will now start the tutorial. Open the content view and then on line 22, enter the following. To do, and then type in results view. And then the next thing to do is we need to create a new struct and we need to call it question view. So what you need to do is create a new file. Just click on file and then new and then file and then select Swift file, click on next. Now type in result view. Not result view, I mean question view. Question view. Now click on create. Within question view, type the following. Import SwiftUI and then create your struct. So struct question view let player player. So create a player object, which is the player for the current question. And then type in let on answer selected. Open bracket bool and void. So what this is on line 13, it's a callback closure that is executed when an answer is selected. And now the next thing to do is create some state variables. So just type in @state private var selected answer boolean and question mark, which is an optional boolean. So the boolean could contain nil or true or false. and then type in @state private var show basket ball equals false. And what this does, it shows the basketball spinning on the screen. And let's type in var body some view. Yeah, that's correct. And then type in spacer v-stack z-stack and then image open bracket player dot image. So what this does, it displays the actual image within the image view of the player. Dot resizable dot aspect ratio dot fit dot frame width 200 and height 200. So that's the width and height of the image, which is 200 by 200 pixels. If show basketball has it been declared correctly? Show basketball. So next thing we do is create another to-do. And then type in spinning basketball view. So that's the next thing we will be implementing. And then next, just scroll down and then on line 31, enter the following text, open bracket, is this current or a past basketball player? Dot font, dot title, spacer, so what this spacer does, it just pushes it up a bit, so it pushes this text field up to the view. H-stack open bracket, close bracket. And now we'll create our yes and no buttons. So type in button, open bracket action, select answer, Just making sure the variable is correct. It's select answer. Select answer. Yeah, so select answer. Select answer. So select answer is a method. It doesn't exist as yet, so we need to create it. So just comment this out so it doesn't confuse us. And now we'll create the method, the function select answer. Function select answer, open bracket, answer will selected answer is equal to answer. If answer and player dot is a basketball player, if the answer is correct and the player is a basketball player, show the spinning basketball animation. That's what we're going to do next. Show basketball equals true. Dispatch queue.main .async after deadline dot now open bracket close bracket plus 3. So what this does, it will show the spinning basketball animation for 3 seconds. So we're missing a bracket here. And then type in show basketball equals false, as we don't want to show the basketball anymore. Answer selected answer. So now go back to the button section of the H-stack, which is here on line 37, and now type in the following. Open bracket, text, yes, just for the yes button, dot font, dot title, dot padding, dot frame, min width 0, max width infinity. So what this does, it will set the width to expand horizontally. Oh, we missed out something on line 37. We need to pass true boolean to the function select answer. So that should be true. Now type in dot background color open bracket red colon 0.14 green 0.46 and blue 0.78. And this on line 42, this is the same color scheme that is used within the NBA blue color. Now type in foreground color dot white dot corner radius is 10, just to make the button a bit curvy on the edges, so the button won't really have sharp edges. And now we do the same thing for the no button. So what we can do is we can copy from lines 37 to line 45. And then just paste it after the first button we just created. And then what we do, we assign false. And we assign, or we enter no into the text field, the text box. And next thing we have to do is delete line 52. No, don't delete line 52, just delete between the first bracket and the last bracket on line 52. And now type in color red. And then everything is similar to the previous button, apart from the color scheme. And then the next thing we need to do is add 5 spaces on line 59 or 60. So just type in spacer, type it in 5 times. And then next thing we'll do is compile, just to make sure there's no errors. It's good, that compiled. So next thing we do is return to the content view. So add the following on line 24. Question view players dot players open bracket current question index and then enter the bracket at the end, then open bracket, and then is a basketball player, and then in. So what this does, this is a closure that we're using that will get if it's a basketball player and send that actual value to another function that we will define later on. So let's run the actual application now just to see the layout and to see if it works. So as you can see, it's created the two buttons that we done earlier, yes and no buttons. Although they don't do anything at the moment, and it's got the question, is this a current or past basketball player? So the next thing we'll do now is add some of the photos, the images of the basketball players. So to do that, just click on Assets, and then get your images. I have images on the desktop. So just select all of your images, go to File, select all, and then drag all of your images onto your assets. Drag them here or here, it's up to you. You can do it there or here. So drag it onto your assets. So just select it again. And now run the application again, and we should see one image in the image view. It's just compiling at the moment. As you can see, it displayed the image of the basketball player. So next week, the functionality that we'll work on is to get the is to enable the yes and no button to be more interactive. So when I click on yes, or if I click on no, it displays the next basketball player. Answer, open bracket, is correct, is basketball player. So now we will implement the actual function called check answer. To implement this function, just create that actual function signature on line 20 or after line 29. So just type in function check answer, open bracket, is correct, bool. So what this function will do, it will check if the answer provided by the user is correct and update the is correct answer property of the current player. So to do that, just type in players, player, open bracket, current, question, index, is answered correctly equal to players, open bracket, current, question, index is basketball player equal to is correct. And then the next thing we do is create an if statement. If players open bracket, current question index is answered correctly, then score plus equals 1. So if the question to the answer is correct, just increment the score to 1. So the scores will be 1, 2, 3, 4, depending on the amount of times the answer is correct. And then the next function we need to create is called show next question. So just type in show next question. And the purpose of this, it proceeds to the next question or shows the results based on the current progress. So to create the actual function show next question, just create it after line 39. The function show next question and then type in current question index equals 1. So what this does, it increases the current question index to move to the next question. If current question index is more or equal to players dot count so what this means, if all questions are answered, set the show results to true to display the results view, which we'll do now. Show results equals to true. Else show results, else show score, is equal to true. So what this does, if there are more questions, set show score to true to display the current score, like the current progress. So score is 1, score is 2, score is 3. And then type in dispatch queue main a sync after deadline dot now +3 with animation show score equals false. So what this line does, it will show the score for 3 seconds, and then the score will disappear at the bottom of the view. So the next thing we can do is, what else can we do now? So navigate back to line, or after line 26. So the next thing we'll do is add the show score functionality that shows the actual score within the text, like a label or caption. So just type in if show score text. So if show score is true, then show the score. So text score, and then this shows the actual value of the score. Just add a bit of styling, font, dot title, dot animation, dot none, dot transition, opacity, dots on appear, dispatch, queue, dot main, sync after, deadline, dot now, +3. Show score equals false. So after the 3 seconds, the score will be invisible. I think we're missing the full stop on line 30. There's an error, cannot find title. So we need a full stop there. So now let's run the application to see if it's working or not. So is this a current or past basketball player? Click on yes. And that should increment the score to 1. Is this a current or past basketball player? Click on yes. The score should now be incremented to 2. And this one's no, this is Brad Pitt. So click on no, it should increment it to 3. It seems like this functionality isn't working properly. So I think we have to go back to the question view. So go back to the question view and then navigate to select answer function, which is this one here. But it seems like we don't have a condition if the answer is no or false. So what we have to do is on line 77, type in else. So what this will do, if the answer is incorrect or the player is not a basketball player, wait for 1 second and then trigger the callback. which is this dispatch queue main dot async after deadline dot now +1, and then to execute the actual callback or closure, just type in on answer selected open bracket answer. So now this should work, because this was the line that was missing. As you can see here, it includes the line. That's why it works when we click on yes, it's a basketball player. And we need that bracket there as well on line 78, this bracket. So now let's try and run it again. Oh, we're missing another bracket right here. I think that should do it. So let's try and run it again, see if it works. Is this a current or past basketball player? Yes. The score should be 1. And then yes. The score should be 2. And then no. The score should be 3. Yes, it seems like it's working. Yes. No. No. Yes. As you can see, the application crashed. Seems like we need to do some checking to do the index. So let's try and fix that now. So what we need to do to stop that from crashing is add some validation on line 23. So what we'll do, we add this. If current question index is less than players.count, then call this function and this closure. Yeah, that should fix it. Let's just try it now. See if it crashes or not. It shouldn't crash now because we're checking on the actual index. So, is this a current or past basketball player? Yes. Score should now be 1. Yes. No. These are actual basketball players, but I just click on no just to test the actual score functionality. No. As you can see, the score isn't incremented. This is an actual basketball player. So I click on no as well, and the score will be 3 still. He's a basketball player. I click on no, and the score should be 3. Basketball player, no, which is the truth. He's not a basketball player, so now the score will be incremented to 4. And then this view that's shown at the moment, that will show the actual results view, and the results view is the view that we'll be creating next week. So as you can see, to create the actual tutorial, it's not too tricky. It just includes like if statements and arrays a little bit of like looping or index checking, and a struct. So yeah, let's code. Create a new file by clicking on File, New, and then File, and then select SwiftUI as a view, and then give the name of the file Spinning Basketball View. And click on Create. And then now we can delete the Spinning Basketball preview because we're not using that. Let's delete that. And then also on line 12, we can delete the text. And on line 11, just enter the following. At state private bar is animating equals false. And what this does on line 11, it's a state property to control the animation. The animation will be to enable the ball to spin or not. So that's the purpose of line 11, it's a boolean. And now on line 13, just type image, open bracket, and then type in the name of the image, which is basketball. And this image should be saved in your assets somewhere, for example, here. And it has to be the same case, basketball with a capital B and a lower b at the end of the word. And then type in dot resizable dot frame width 75 and height 75. So that's the size of the basketball. Dot rotation effect is animating question mark angle degrees. So this just means it's going to animate all the way around 360 degrees. Dot 0. So there's a mistake here, I think. Degrees, angle, open bracket is animating effects. Oh, it's the bracket. There should only be one bracket at the end. Dot on a pair with animation dot linear open bracket duration 3 repeat forever auto reverse equals false. So what this will do, it will start spinning the animation when the view appears. And it will do the actual animation for 3 seconds. Is animating equals true. Dot on disappear. With animation. Then is animating equals false. So that's the end of the animation. Oh, there's still an error on line 16. So what is it? I missed out 360 degrees. And then a closing bracket there. And I think something else is missing. There should be the colon here as well. Yeah, let's compile it and see if it works. And the next thing we'll do is try to run the spinning basketball view within the content view. So go back into the content view. Now that was a mistake. The spinning basketball view, that needs to be called within the question view. So go into the question view, and the comments that we created last week, just on comment lines 28. And then now we should be able to run the application and see the spinning basketball. So let's try and run it now. So just click on the run icon. So just select yes, because when it's correct, that's when we see the spinning basketball. If it's incorrect, we won't see the spinning basketball. So the basketball should be spinning near to the player's face, near the center, near here. That is correct. That person is a basketball player, is or was a basketball player. So click on this one for no, and we shouldn't see the spinning basketball because the person was a basketball player. So let's test it. So as you can see, we didn't see the spinning basketball because the person was a basketball player. And this one is this current or past basketball player. Click on no. It's not a current or past basketball player. Is this a current or past basketball player? Click on yes, and you see the basketball spinning, so that functionality is working. So I'll just stop it there. And then the next thing we'll do is to implement the results view. So the results view, it shows the names of the players that you found correctly. So to create the results view, You can either click on File, as we normally do, click on New, and then New File, or you can use the shortcut keys if you want to. So what you'd do, you'd press down the CMD key, the control key, and then you click on New File, and then just give the file a name. This time we're selecting another SwiftUI file, and then name this file results view. Let me just put it in here. Yeah, so what we need now is to create some variables at the top. So just create let's players, open bracket player. This is a players array. Let's score int. Let's on play again tapped, open bracket, close bracket, void. This is a closure that we're creating. So the purpose of the closure is to enable a callback when the play again button is tapped. And then on line 16, just type in VStack, text, quiz, let's type in dot font, open bracket title, dot bold. So what this does, it just makes sure the quiz results text has a font style of bold. And let's type in and then type scroll view, open bracket, lazy VStack, open bracket spacing, 20. Let's type in for each, ID, a comma, ID, dot name. So what this does, it will go through the players' names within the players array. And then type in if player is answered correctly, so if that is true, create a H-stack and then show the player's image, their photo in a H-stack. Player.image. .resizable. .frame width 50, height 50, corner radius 25, text player.name .font title and foreground color green. And then what you need to do on line, or after line 38, just type text score dot font title, and then we need to display a circular progress bar to represent the score as a percentage. So to do that, scroll down and type Z-stack circle dot stroke color dot gray style dot stroke style line width 10, line cap dot round dot frame width 150 and height is 150. And then on the next line type circle dot trim from 0 to CG floats score CG floats open bracket, players score. Players.count, and then the circle is spelled incorrectly. And then type in stroke. Color. Open bracket, red. 0.14. Green. 0.46. And blue. 0.78. Style. Stroke. Style. Open bracket, line. Width. 10. And then line. Tap. Dot round. And then let's type in text, open bracket, comma, calculate, score, percentage. Calculate score percentage. So that's a function that we need to create. Dot font title. And the calculate score percentage will display the actual percentage in a circle. So now let's go ahead and create that function, calculate score percentage. So you can just copy and paste it. And then on line, or after line 59, just type in the following function, calculate score percentage, open bracket, and then int. This will return an int. And then type in guard players.count more than 0, else return 0. And what this does, line 62, it checks if there are any players to avoid division by 0. So there has to be at least one player to do the calculation. Let's type in let percentage equals double, open bracket, score divided by double, open bracket, players dot count times by 100. So that will calculate the actual percentage of the quiz score. And then to return the results, just type in return int percentage. And what that does, it just converts the percentage into an integer and returns the result to the corner. So what we need to do now, go back to line, is it line 53 or calculate percentage score. Yeah, go back to line 53. No, go on to line 55 or 56. 55 or 56. And then type in text, open bracket, comma, incorrect, players, dot count, minus score, dot font, title, dot foreground color, equals red. So what this does, it displays a number of incorrect answers. And next, we create a play again button. Oh yeah, we've forgotten to put a full stop on line 53, which is here. Full stop, then title on this line. So to create the play again button, what you need to do, you just type the following in button, open bracket action, on, play again tapped. And then type in text, play again, and type in dot font, dot title, dot foreground color, dot white, dot padding, dot background, color, red, 0.14, and green, 0.46, and blue, 0.78. As I said last week or the previous week, these are all the NBA colors, the color schemes. Dot corner radius is 10. And then on line 74, type in dot navigation are hidden. It's true, so that hides the navigation bar. So now let's compile it and check for any errors. On line 52, we're missing some brackets. because this is a function, we need to provide these brackets here. So it should be a bracket there, a bracket there, and a bracket there. And also the percentage sign symbol, which is there. So let's compile it again, see if it compiles correctly. Yes, it compiled. So now we need to go back to the content view. And then on line 21 or 22, or after the spacer, so it's up to you. Just type in if show results. Open bracket. Then type in results. Result view, we can select it on this line. Result view. So we pass in players. Got players. And the score. And yeah, that's it. So we don't need that parameter there. And just delete that one. So what this does, it will show the result view when all questions are answered. And then we need another one of these brackets. And then we need to also type in reset quiz. We have to create that function afterwards. And then so what do we need to do now? Oh, we need an else statement to go with the if. So all we need to do, bring this if statement up to line 26 and type in else if. And now we have to create the actual function, reset quiz. So to create that function, just scroll down to line 46 or 47 and type in function, reset quiz. Current question index is equal to 0. Show results is equal to false. Show score is equal to false. And score is equal to 0. So what that does, it just resets the quiz by resetting the state properties and marking all players as not answered correctly. Let's run it now and see if it works. Okay, so now click on yes, basketball player. yes. And I pretend to get these ones incorrect. So I just say yes. It should be no, really. I say yes. I say yes for this one. Say no for this one, but it should be yes. And I say no for this one, but it should be yes, because they're all basketball players apart from the actor. And I say yes for this one, but it should be no. See, as you can see, it shows the amount of players that were correct in the quiz, and it shows the actual percentage. But there's a little error with this circle here. So we have to go back to the other view that we was in. I think it was the results view, and we need to fix that. It seems like we forgot to add the frame and rotation effects on line 51. So the frame is the frame of the circle that states how big it should be. Frame width is 150 and height is 150. Dot rotation effect dot degrees open bracket minus 90. Let's see if this works now. Do yes for this one. This time I do no for this one. Do no for this one. I do yes for this one. And then yes. Then yes. And then yes, which is false. So as you can see, it displays the correct results, this time with the correct percentage and the correct circular shape and size. So these are the actual names that I matched up correctly, if they're basketball players or not. And these are the photos for each of the players. And I scored 71% and I got 2 incorrect. So if you want to play again, you can just click on the play again button. And to make this quiz more realistic, you could have the data coming from a JSON API, like from a web service, or you can have it coming from like the actual NBA web API to make it more realistic. So this is the end of the tutorial, and I hope you enjoyed it. The provided code implements a quiz app for identifying basketball players. It utilizes various SwiftUI views such as Content View, Player Quiz View, and Results View to present the quiz questions, display to the results, and handles user interaction. The Player Manager class manages the list of players, and the NBA title view adds a stylish title to the app. Overall, the code showcases a basic structure for a quiz application within SwiftUI. So that's the end of the tutorial. Please comment, like, and subscribe if it helped you in any way. And